All right. Let's see if this ever shows up. Test. Right, I need to mute. Okay. All right, lag is not too bad. All right, so hi there. Welcome back to another episode of me doing some programming. Let's do some administrivia oriented to archive, since not all the people watching the live stream are going to be here yet. So let's see what's archive specific. I can't actually think of anything that's specific to the archive. So let's do some stream specific stuff that's not OBBG. I have messed with my OBS settings since the last time I streamed OBBG. I bumped up the frame rate. I think I had set it to 15 before, and it's now 30 because I was streaming a game, or I don't remember why. And I originally set it to 15 so it would be a little higher quality to make sure the text would be readable. I assumed that lower frame rate could spend more bits per frame, but I don't know if it actually does. So the main thing is just, make sure the text is readable. The other thing is I probably changed the font size here. So again, I can bump the font size up if needed, and that's why there's that little thing about it. Okay, so I can't tell how many people are actually watching. For some reason that thing isn't showing up on my Twitch view. Am I on the wrong page of this? I forget how this frickin' Twitch stuff works. Is there a different view that was better, like a dashboard or something? Anyway, sorry. So I guess we should get to it now. So let's talk about some stuff from the previous stream. So about 3 months ago, because it's been like 9 months or something, 3 months ago I rewatched it. I don't know how much of it I rewatched the last episode. I think I watched the whole thing. And I noticed a big error that is not a bug, but it is an error that we will revisit. And second, I just rewatched about 45 minutes of it today and noticed a bug. And it is a bug that then no longer matters because it's not using that part of the code anymore. But we should just go ahead and fix it just in case that code ever does get used. Except, I guess, oh no, I'm looking in the wrong place. Where was it? It's where it decodes the packets. Yep, right here. Obj 0. Pretty sure that should be obj 0. Now, maybe not, because there's some weird stuff with the authoritative stuff. So maybe that was a thing where I was intentionally sticking that stuff in object 0. It's been so long since I did it. But if that's the case, it should still only do it if it's the player facing. It still should be sticking this facing in for everything but the player. So we'll make that change now and not worry about it. And the third thing I wanted to say about what I was doing the last time, which this will more apply to the archive view, I guess, is that I decided to implement a pretty complicated set of logic for this networking. And I didn't do that incrementally. I just kind of dove in head first. And I do that for a lot of stuff, and I think it's okay that I do that for a lot of stuff. But the problem with networking is, let's be clear, I have no idea what I'm doing with networking. I have book learning on networking, but I've never done it before. And the book learning has gaps like that I have identified. I'm like, nobody explains this part. I don't know what I'm trying to do with synchronizing the quote unquote synchronizing clocks. It's not literally that. And there's the big giant question about how the server is supposed to be friendly to the client set prediction. So we'll come back. So if you're watching, keep that in mind that I don't know what I'm doing in this particular department. So don't take anything I'm doing as necessarily the right or great way to do it when it comes to networking. And because I don't know what I'm doing, maybe diving into the complicated design was a bad idea. And there's some incremental steps I could take along the way. Now, the thing is, I'm probably already past most of the issues that stuff would do. For example, there's this whole buffered input from the player because we want to simulate ahead of how to put this. We want if a client packet is late, we don't want to throw it away. If the player tried to do something and it's just a little late, we don't want to have them not do the thing. So we delay all of the client behaviors, all the client input by some amount to try to have some room for that fluctuation. And that's where the whole clock synchronization fuzziness comes up. And I forgot to check that my audio is working, but nobody complained about it earlier, so I assume it is. What was I just saying? The player input buffer. So the easy first initial test is to not buffer the player input at all and just always use the most recent player input you've seen, and it'll be a little inconsistent, but that would be better testing. So if that stuff is still broken, I will probably try to switch to that, to just always using the most recent player input when simulating the physics, and that will step around that problem. Before we then get, and maybe I should do that for everything. Maybe even though I got past most of those things, maybe I should kind of not start over exactly. I can still reuse all these physics packets that I've designed here, although they're all, as I've probably said last time, I shouldn't actually be using structs for this stuff at all. This was sort of a placeholder to get it going. I could keep that stuff and just try to incrementalize some of the other aspects of it, or I can try to keep going with what I have, and I haven't quite decided what I want to do for that. But the other thing I noticed 3 months ago when I was looking at this is that I made this thing I just called an error. It doesn't lead to any bugs, it's just a misdesign, and I don't know where this would be. It's network specific, I guess, so maybe it just lives in the network. So I did a bunch of math to try to decide how many objects we could have in the world, because where I don't know where that lives. Oh, here it is down here. And I said, hey, if we have that much state, you know, I would like this to have not be limited. Like games tend to run at certain sizes, and some of that is design, and some of that is bandwidth, and some of that is the server being fast enough. And I don't know whether people who are doing it that way have made all of the right trade-offs, in a sort of HandmadeDev sense. So I've got to answer something on chat real quick. So the logic here, so this is all wrong, but I want to explain the logic here so I can explain why it's all wrong. So I did this math and I said, wow, this is going to require way too much storage. Even this is going to require way too much storage. This is a problem. Oh, right. I was saying I would like to have this not have many constraints on the memory front, so that the performance, so the limitation on how many objects and players you can have in the world on a single server is strictly from the performance, and then try to optimize the performance. So that was what I was saying in a handmade sense. And so I was doing this math, and this math is crazy math. And it's just, I wasn't thinking things through 100%. But so here's the idea. Say that what it needs to store as state per object is 64 bytes. And say you have 32,000 objects on the server, perfectly reasonable. Why is it times the number of players? The idea here is that for the sake of networking, we want to keep track of what the player, each player independently thinks is the state of objects, so that when we do their networking updating, we can do it relative to that, basically. You can, in certain ways, and it has to do with the interpolation, it's a little more complicated than that, but that's the good quick summary. So we need to know what every player thinks of every object, so we have to keep a separate copy of that. And then when you do lag compensation for a shooter, sometime in the past, the client tried to shoot at someone, and you're trying to be client server-side authoritative. So what you want to do is, when you get the message that the player shot at someone, you want to validate it. But you don't want to validate using the current state of the world, because it's what the player shot at. You don't want to validate against what you just sent. If we only keep one version, you don't want to validate against what they just sent, because that's not something the client has seen yet. Instead, the client sends a timestamp, and you have to go back in your history and say, here is where that object was at that time in the history, and we'll use that when the player shoots at them. And so I arbitrarily said 16 versions, and I did the math and found that this took 32 gigabytes, and since this is running on a 32-bit thing, that's not feasible. So I tried pushing the numbers down, and that still got me out in a bad place. So there's a couple obvious things that are incorrect about the original analysis. First of all, we only need the most recent version that we sent for the sake of the networking, pure networking, not lag compensation. If we want to do lag compensation, we only really need to do that for things that the player shoots at. Now, it can be a little varied. If there's if a tire goes rolling across the screen and that blocks the shot, we probably would like to know where that tire was. But it's quite possible that a lot of objects don't need lag compensation, which means we don't need a full product against this. In other words, it would be more like, you can have 30,768 objects not lag compensated, and let's say 1024 objects lag compensated. And now when you do the math, this one is times 1024. This one is times 1024, saying 1024 players. This one, we only keep one version for each object, the most recent version. And this one is times 16 still. And then this is all 64 bytes per object. And then if we run that math out, I haven't even done it yet, presumably those sizes are a lot smaller. You have to add these two together, but the point is that this one is much smaller, and this one, this one is smaller by a factor of 32, and this one is smaller by a factor of 16. So we bring this down by a factor of 16, I guess, which is 4, so that's 2 to the 31 already. But we're not done. We don't need to keep this state for 32,000 objects for each player, right? So this is, we should make this clear. Let's say this is connections. Let's make it explicit that this is about connections. And then, all right, so still the same product, but make that more explicit. So this is still 1024 connections in either case. Yeah, now I want to write justify it. So we're not actually going to send the state of 32,768 objects to each player. Now we could have a world, maybe you have this big, 32,000 objects isn't even that big, but so you have a moderately sized level. It's not an open world, continuous world. You just have a really big level. It's got 32,000 objects in it. Then one way to implement that when you have a single fixed level would be to have every object being communicated across. But when you have an open world, Minecraft style world, it's pretty clear that you can't send all objects because you don't even know what all objects are, right? They're not loaded. You haven't even spawned the terrain that those objects exist in. So all you're going to communicate to each client is the objects in some radius around them. And you can do the same if you have a really massive level, even though it's not a continuous infinite world. You could do the same kind of, there's this context around the player, and those are the only objects the player is aware of. So what we can change this to is that the only thing we need to keep for connection state is some smaller number of objects, the number of objects near the player. Say that. And then, of course, you still have the lag compensation. And the problem now is that this is now the dominant factor, and we've still only, from this original number, we pulled this down by a factor of 32, but we didn't bring the rest down. So we can push this down to 8. So 8 versions. Now you could definitely say, well, if there's 1,000 players in the game, they're not all going to be in the same vicinity, so we could knock this down to, say, 64. But I don't like that, because one of the things that you hear happening all the time is that people all get in the same area in a server, and everything goes to hell. Now, some of that going to hell is real. If you can't render, if you have these really detailed character models, you may not be able to render 1,000 players. But I'd prefer not to bump that down. On the other hand, it could be that for the sake of lag compensation, you don't need to store all of this state. You only need to store the position, say, and you'll interpolate the positions for the sake of lag compensation. So we could bring that down to, say, that. And now at that point, that's 2 to the 10 times 2 to the 10 times 2 to the 4 times 2 to the 3. And that equals 2 to the 27, which is what? 128 megabytes, which is totally tractable. Is that actually right? Would be a factor of 8. Yeah. So 128 megabytes is still huge. And that's only for this right side. And then the left side is, I think, half that. So the actual math that I discussed in the previous thing can work out much better. What do I usually drink in dark container / bottle? Well, this is what I drink these days, if that's what you were talking about. And it is a SodaStream diet root beer. It's not actually a dark bottle, it's a clear bottle, right? So anyway, so I just wanted to correct myself on that. It's not anything we're going to change at this point. Like, somewhere there's some pound defines and I could go clean them up. You have to do some kind of mapping here because you're not sending all the objects across, so you want some efficient way of accessing them, a hash table or something on the objects. So yeah, the t-shirt, by the way. Oh, I guess if I go backwards, does that work? Yeah. Anyway. What keyboard is it? It's a DOS keyboard. I guess it's the red. I think we discussed this before and I don't remember. So, oh, and I didn't juggle. Sorry, should have done that in the pre-stream. So anyway, we're not going to worry about it. But that was a pretty big mistake in the last video, or maybe the previous video. So this is much more sane, right? 128 megabytes versus 32 gigabytes. The idea here is that this supports everything that, instead of doing that thing where I started shrinking the size, where is that one? Oh, I deleted it. No, it's down here. Instead of this, where I tried to shrink the sizes to make it all fit, no, you don't have to shrink any of the sizes. We can still have 32,000 objects and 1,000 players. And I guess I did shrink it down to 8 versions. We don't even know if we want lag compensation. Like, that's a very shooter specific thing. You don't need it if you're not doing that kind of shooting thing. Yeah, there is a FAQ, but it doesn't have the keyboard in it, I don't think. Although it is a FAQ at this point, so it probably should. All right, so I think that's it, and now we get to programming. So, yes, and one of the things I wanted to say again about why I rushed into this networking and why it was bad, that I didn't do the incremental steps. So I think part of my motivation there is that it's a pain in the butt to test the network stuff because I have to open multiple windows and select the right one. And so I just kind of wanted to skip to getting it working. However, it is even more of a pain in the butt to debug networking stuff. And so despite it being a pain to test and me having the iteration on that being pretty slow when testing, it's probably still better to take smaller steps because the debugging is so painful. All right, so the first thing to do at this point, I think, is verify where things are. So let me just open a new command window. Did I use a smaller command window? I don't remember. And put that there. And I can hide that now. And I need to put this into purge OBBG, purge games OBBG, and then it's VC6 debug OBBG, I think. Just check that. Okay, so here's the broken client. Well, there's no server running, so the client is super confused. I can aim the camera, but it's latent, and I don't know why that's latent given that it's supposed to just be authoritative locally. So maybe I should fix that. And then I can run, okay, and this is set to run the server here. So there's a server running, and the server still does all the full graphics processing because I've never gotten around to that. And then we run the client. And now it's trying to communicate with the server, and it's weirdly laggy. And it is correctly directional dependent, and it's got this crazy jump that I talked about in the last video a lot. And I don't know what's causing that, and I have to figure that out because that's one of the biggest problems. And the other big problem is that if I go far enough, I start going through the train, and oh, I just accidentally skipped by. It focus stole when it popped up an error, and so I didn't get to see what the error was. Because I was pushing a button right when it did the error. Okay. So the thing I did last time is I tried to avoid the collision system having an out of range problem that involved a Z in and a zoom in. So I suspect this is the same thing. Physics move walkable. Okay. So I guess we're right into debugging the thing I was looking at that I thought I had fixed. Z epsilon is very small. Z is no longer smaller than min Z. Min Z, I have that though. This takes a floor after adding and subtracting, so that actually maybe moves it down. So it could be that it's already too small before we get there. I accidentally covered up the chat. I'll uncover it in a second. There's the jump. All right, which one was it? Yep, okay. So this isn't even the right test. Move bottom to floor of current voxel. So the whole idea is that we're falling. How big is DZ again? Not very big. I've already overwritten Z is the problem here, so I don't know what it used to be. I guess I can reconstruct it. Min Z minus DZ. Whoops. Min Z minus DZ. Oh wait, DZ is positive. We're moving up. Okay, this is saying falling doesn't mean we're falling down. It means we're not in contact with the ground. Okay, so we're not in contact with the ground. We try to move, we get a collision. We try moving along just one axis, and they all collide. So now what we wanted to do was yeah, this is just all wrong, because if we're moving up, this doesn't make any sense. What we want to do is move as far along DZ as we're allowed to, I think. Unless there's some other logic somewhere that does that. I don't think so. I think that is what we need to do here. All right, let me uncover the chat. WinSock or cross-platform lib. I'm using SDLNet, and I'm supposed to switch off of it because SDLNet is apparently something you're not supposed to use because it's ancient bullshit. It provides functionality that you might as well do yourself, and was written in a day before everyone knew that IP had won. I think it was like to actually allow like the old LAN play on the network, on the Novell networking or whatever it was called, or something, some sort of story like that. And I mentioned I was using SDLNet, and one of the SDL people was like, "What?" So somebody else has offered a nice simplified. The main thing is just that you want to use sockets, and I'm totally comfortable using sockets. It's just you have to do them a little differently in Windows and Unix, and I'd like it to be cross-platform. So somebody, I think, at some point offered one of those, and I don't remember who it was or where it was, so I probably, since it was 9 months ago, probably don't have ability to look at that anymore, but it's something I should fix at some point. All right. So, blah, 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 blah. So yeah, I think this is just buggy, incorrect logic, except that this only triggers when I'm doing networking, which probably implies that either it's right in some subtle way that I'm missing, or just it only is being exercised by sort of extreme values that are happening due to some other bug. And it's good enough for now, but since I don't know where that other bug is, it's probably still easier to just freaking fix this. Now, the really noticeable bug was that jumping up thing. And here's the thing, where do we ever increase the value of vel arrow z? When we fall, we at some point add gravity. Where do we add gravity? Do we ever add gravity? Z, but we don't DZ. Where does DZ ever change? Oh, it's not in physics walkable. It's somewhere else. Yeah, you just gonna have to bear with me pushing the stack. What? Physics, move, walk, able. Sean, purge, games, OBBG, look in subfolders. What? Okay, I don't know. So world.c. Okay. Boom, right here. If this returns 0, then we're in midair, and it adds velocity. Why it does it here and not inside physics move walkable, I don't know. Oh, because you might be flying. No, if you're flying, I just let you, yeah. That's probably dumb. It's probably dumb that it's outside that. But the idea is that physics move walkable is just trying to get you on a straight line. But probably should be split up differently then. You should probably just take the initial point and the end point, and then the job of physics move walkable is to figure out where you end up when you're trying to follow that path. So if this returns 0, so default result is 0. If it returns 0, then you fall, right? That was what we said, yeah. So where does result ever get set to 1? Okay, this is the only place it gets set to 1. Oh, no, here. Okay, right. So, since I got fooled by this, let's make this clear. Not in contact with the ground. And then this case is in contact with the ground. So if you're in contact with the ground, you don't try to fall. If you are not in contact with the ground, then when you return, it will increment the DZ, and then the next time you come through, you'll try to apply that DZ and fall further until you hit the ground. And then here, in this case, this is the case where we're detected that we were not in contact with the ground when we started, but at the end point, we're colliding. So we're trying to say, we did collide, let's move ourselves back to the ground. However, if you jump up and hit a tree with your head, this doesn't work. None of this logic makes any sense. I think that's the case we're hitting, and then that would be being caused by the jump up. So, okay, there we go. That all makes sense. I have convinced myself. For those who are curious, when I program not on the live stream, I think all those same things, but I never say them out loud, I think. I believe that's what happens. So let's just assume that these are different cases. I don't know if that's actually true. So if DZ is 0, we're going up. So we're never going to land on the ground. So what we want to do is we want to move as far along dx, dy, dz as we can without what is the point of these tests? These tests are trying to say, can we be blocked on one axis, and if we are blocked on the one axis, kill the velocity on that axis and allow to move in that other direction, which lets you sort of push along walls. But this is the mid-air case. This logic really belongs down here. All right, well, we'll let it be for now. All right, so we tried pushing along the walls and got no good results. So the idea is that I can see why Casey has the drawing thing around. I was trying to not be at this level of explanation for this channel so much, but I'm trying to not be beginnery, but I probably should still, if an illustration is the easiest way for me to state something, then I might as well illustrate it. So the idea is if you're at this point and you try to go to this point, then there are a bunch of cases. And what we look at are maybe you're up against a wall along here. Right, and if that's the case, then let's move you to there. Now the thing is, you won't actually push up against the wall if that happens. Will just kill your velocity, and you might be a little bit away from that wall. This is, just kind of hacky, get it work in physics. So we checked whether that was the case. Is that unblocked? So we know the endpoint is blocked. We know that along that axis is blocked and that axis is blocked, and all three axes. No, not all three. Right? We didn't treat. So this is like a top-down view. So we tried moving, still following the Z movement, allowing the vertical movement, but trying these two variants, and they didn't work. And we tried not moving here, but also moving up. So now let me switch to a side view because this is too confusing, since the important dimension is the up axis. So we'll just pretend that that's a 3D world, but one of your axes, you're not even trying to move along it. So what did we try? We tried moving to where it actually requested, and that was blocked. We tried moving without the Z movement. Did we try without the Z movement? No, right, okay. So we haven't tested this. This is important because that's what we're about to do, I think. Or maybe that's what we need to do. Okay, right, yeah. And we did test this, and so both of these were blocked. So we're trying to figure out what's the best approximation we can do to going to there. So one thing we can do is we can try to go to here. And when we're pushing along a wall, that makes sense. But if what we're doing is following a little parabolic arc, or in either direction, so the other case, right, is that we're falling, and we have not yet tested this one. I just drew it as being tested here, but we tested. No, yeah, we tested that endpoint and it didn't work. And then we tested what happens if we just fall straight down, and this was blocked. But we haven't tested. We've tested that. We haven't tested what happens if we just don't fall, because it doesn't really make sense for you to move horizontally but not fall, right? That's not what this trajectory would do. If there's like a floor, if there's a solid block here, we don't want to teleport you over to here and have you land on that block. Now, mind you, all of the distances being traveled here should be really small, but we'd like the OBBG system to work if you set your voxel sizes to be, an inch. Like, there's no reason it shouldn't work. So we want to avoid teleporting you onto this thing. It's okay to have you fall straight down. You're falling still, right? We haven't changed the fact that you're falling. So let's catch up on chat. I saw some things aimed at me, but I want to. To follow up on that reply to Quartertron, so there are two different voxel rendering engines. There is OBBG, which there is a playlist of a whole bunch of videos of me developing it, but it just uses STB voxel render. STB voxel render itself, there's a trailer for it showing the feature set, but there's nothing about how it was coded. Oh, of course, you addressed that to me, but it wasn't a question for me. You were applying to someone else. Right. And it's not a criticism. It's just me being confused. Okay, so we don't want to allow the case where we don't apply the Z, because that is weird. As much as possible. Okay. None of this is an accurate physics simulation. Like the correct physics simulation to an approximation is to follow this parabola with a swept out Minkowski sum and find what that hits. And, if that hits this corner, that's where you have a contact, and now you do an impulse and you resolve it. What we're trying to do is do game physics, which are not as accurate, but are accurate in the basic important cases. And that directly solves some problems that you commonly want, which is in a first-person shooter, when you're running along and you run into a wall, you don't want to get stuck. You just want to push along the wall, and if the wall is at this angle and you're going like that, then you hit here, say you're a box, just to simplify it, and this is how far you should go on each frame. Then what you want it to seem to do is, if this is your velocity, it should push you that far. Well, there are two ways to view it. The wrong way to do it is say, well, it should push you that far, except it's got to be along the wall, so you end up here, but now you've actually traveled further. So what you want to do is either travel that distance rotated at an angle, which I didn't really draw those arrows the same length, so this is kind of screwed up. It's the second, this makes those two arrows more look the same length. So you want to travel that far along this angle, which is a little bit shorter, or you maybe even want to travel less far because you're pushing against a wall, so you lose speed. You know, that's totally fine. And there are various ways to do all that. And your regular physics system can be made to do that, but you can also just do this logic sort directly. And when you're dealing with just cubes for the voxels, and your player object is a cube, and you don't allow the player object cube to rotate, which is what we'll do for the physics object of the player, not for his graphics, then like the rules are really simple, and so we can actually apply this simpler logic that solves things directly, but it doesn't handle the weirder cases that physics engines handle, like when you have joints or you have an object pushing on an object pushing on an object. So we should be able to get something that feels just like a good physics engine. And if we don't solve this parabola at this level of detail, we'll get some behavior that is not the correctly simulated result, but that is a result that could happen with sort of a slightly perturbed input, which is good enough. So anyway, so at this point, we know that if we're following this trajectory, this one and this one are blocked. And if we're following this trajectory, this one and this one are blocked. So if we're going up, it's actually okay to just go across to here. You know, we're following a flattened version of this trajectory. Now, we'd want to know, like, oh, there's an object here. It should hit that and there. It should not get under here and go here. But it's okay if it gets under here and goes here. Like, that's a, single frame. Like, there's almost no scenarios where this would ever happen. But it would be totally fine if our engine did that. What we would want to do is say the player object is this tall, and we're trying to get him over here. We still have to make sure that he fits this way, whereas as I've drawn it, he'll collide right here. So we don't want to strictly teleport him along. And the falling case is similar. So what this existing code was trying to do was, it's like, okay, I have the player here, and he wasn't allowed to go to here, and he wasn't allowed to go to here. And so what I'm going to do is, instead of trying to follow this path, I'm just going to go straight down as far as he goes before he collides. But the problem is, in the upward case, he just gets to keep going, and he never collides. Actually, I think he tries to push him downward, and it just is totally wrong. He's in midair, he should be hitting the ceiling, and he starts getting pushed downwards, and it tries to push him downwards until it collides, because it knew that when it tried to send him along the full length, it collided. So it's trying to probe how far along do I have to go before I hit. And the way it's probing, because it's following the vertical line, is it's just checking each successive thing with this loop. So I think this loop works for the downward case. Now, I'm not sure saying it's the right thing to do. An alternative thing to do would be to say, let's follow this trajectory, and approximate it with a straight line, and let's go as far along that as we can until we collide, and step back once and say that that's where we got to, and then start falling straight down. However, we eventually need the falling straight down case to work, because the falling straight down case is how we end up with our feet on the floor, so that this test here with the epsilon catches that our feet are on the floor. So the simpler thing to do is keep that existing logic that we had, and now we need different logic for going up, and it's probably just doing this. And now it's no longer min z, it's really max z. And I bet this was the bug, because, I mean, we still have the bug of why is it jumping up, but I bet it was just jumping up and hanging its head on the thing. Okay, no. So this won't quite work, because what this is trying to do is, okay, floors it, so it puts the feet at exactly the ground plane. But we don't want the feet at the ground plane now, we want the head at the ground plane. So, how does this, wait, but plus, what the fuck? Okay, like 0 is the min and 1 is the max. So this is the height. So we take half of the height. Oh, this is IZ, which is just used for gathering the thing. So it's just trying to find the center of the guy. Okay, so this is the bottom, and this is the top. So now we find the top. We want to clamp the top that way, and we push it back down, and then we say, is he less than equal max z? Is he less than equal? Now This might be fuzzily. This will allow the very top of the player to be exactly flush with the voxel, which I think I don't want. I think I'd rather it never have the top exactly flush with the voxel. I think I'd rather have it stop an epsilon away. So we're going to do this. Minus the epsilon. And then it subtracts another epsilon for these things, but whatever. Oh, this needs to be plus, because this is trying to allow for some plussiness. And let's actually minus the epsilon here. Now, if the player were exact multiples of voxels, this might be bad, but I think this is fine. Let's just test it. Wait, why? Oh, it's actually still running. Okay, so that's the server. Kill our wonderful drawing. And here's the client. So I should still pop up, but it shouldn't crash when it pops up anymore. I hope. I mean, it shouldn't pop up, but obviously it will. Well, I wasn't under a tree when it popped up, so doesn't prove anything. And what you can't tell is that this is still super latent. Oh, and now I'm stuck. So I either the physics just pushed me inside an object, and so I'm stuck, or the physics is stuck. Well, info buttons is displaying nothing. Let's check if that's still active. That's supposed to be the player. Oh, and now it's spazzing because I need to restart the server. Oh, okay. So buttons are 0. Now I hold down a button. Okay, and that shows. So the buttons got out of sync. That was why I stopped moving, because they all showed 0. And I don't know why that was. So that's the thing that I need to add the logging for. I probably want to figure out where the jumping up is coming from. There it goes. But at least it is no longer crashing due to the dumb physics thing. Which was a bug. Which was just a straight up bug in my dumb physics. Okay, I got wedged in this object again. And my buttons are stuck. Okay, the buttons, it's ignoring my buttons, but it just has whatever the last button value was. So then why, if I got stuck in a wall with this client... Oh, I thought I saw buttons flicker. Yeah, I don't know. And the thing that you can't see, of course, is that all of this is super laggy. Because like none of this stuff works. The client authoritative stuff isn't working, and etc. All right, so I need to debug the client. So let's run the server here, and then run the client and get stuck, and see what's going on inside the client when we get stuck. Oops, I tried to run a second server. All right. It's not even letting me move. Oh, there it goes. There's a jump. So it seemed to be when I ran into a tree. Wow, I seem to bounce off the tree, but there's no code to bounce me off of things, so it couldn't have. So here's an interesting case where I'm not pushing along. Oh, right, because the push along code only works if you're in midair, because I was an idiot. And I did that first. Okay, now I can't get it to get stuck anymore now that I have the debugger running. Thanks. I don't even remember what those matrices are. Oh, that's part of the rendering. Any questions while I'm boringly just trying to perturb this bug into happening again? It might only happen if I'm not running in the debugger. That would be awesome. What would be the performance gain? Well, very little performance gain to the key rendering because the rendering is all GPU limited. The big issue is the building of the voxel stuff. which is sort of a limiter on how fast you can move through the world because it has to build the vertex buffers or generate the world. And so that's a good question. Somebody needs to actually build it on a modern compiler and tell me, wow, big jump. Did you guys actually make a Jeff in case you showed documented? No, that was just a joke for that season. There was the whole fake company that I don't remember the name of it that had something to do with that, I think, too. I don't remember the details. But it was around that same time, right? There was something about a questionnaire. I can't even remember. I can't remember the plot of that. But yeah, that was just something Jeff and Casey wanted to do. Fixed variable, how you decouple rendering from physics. Right now, for gameplay reasons, you're actually always better off using a fixed time step in your simulation. If you use a variable, I used to use variable time steps. That was very classic. Looking Glass did that in our stuff, so that when you ran on a slower machine, you know, your time step was covering a longer time slice. And there are a couple of issues with that. With certain techniques for implementing physics, a long time step can blow up. So sometimes people in the physics area say, hey, you know, split up your variable time steps into fixed length time steps. But if you have, say you have a platformer with, you know, sort of pixel perfect jumping, you need that simulation to run exactly the same. Here, let's take this case. Suppose you have a replay system that lets you lets you send a replay to somebody else and they can replay. Well, that could have the time step in. That's not a perfect thing. That just makes you decouple it. The strongest argument is that, like, you've set this thing up so that, let's say, you know, you've set up a trap so that when you step on this plate, it triggers this the simulation-y thing that, I don't know, you know, triggers off this other mechanical thing that swings, and you're guaranteed that if you do it exactly perfectly, you have like one frame to get through. And so all you have to do is hold the stick right and you get through. You just have to, you know, and that's not totally unfair. Like, if you could imagine a scenario like that, that's not totally unfair. Well, if you use a variable time step, the way that's going to behave, the timing of those things, is going to change depending on the time step when the player's playing it, and it might not actually behave consistently. Whereas if you use a fixed time step for your simulation, meaning both physics simulation but also game system simulation, then you're guaranteed that the player kind of always hits it the same every time they play it because the time steps are the same. That's not actually 100% true in that scenario. Like, as you're moving, if you are allowed to move sort of sub-pixely positions, you know, you might have started at a slightly different position when you started running, and so you're half a pixel over in one run versus where you are in another run. But it's just way more consistent. And it can just be as simple as, can you make this jump or not? If you're writing sort of game logic physics, and you don't do a parabola interpolation perfectly, you're throwing some, you know, simple linear segments at it. You linear segmentize every time step. You could have a case where people actually have different jump distances depending on the frame rate. Now, obviously, if you use a smarter physics engine, you can avoid some of those kinds of things. But that's something that just applies to the whole simulation all throughout. So I think, and certainly other people have said the same thing, that they think it's just better if your simulation just always uses a fixed time step. It guarantees you a certain kind of consistency that, for game design reasons, is important. So then the question is, how do you decouple the rendering from the physics? Because now you've got these physics steps are forced to run at, say, 60 hertz or whatever, and then you need the rendering to draw. So at the moment, I just drop the intermediate frames, right? I just use whatever the most recent simulated frame is for the rendering. What you can do is interpolate the two most recent frames. Like, imagine you only ran your physics at 10 frames per second. You know, and this happens when you get network input at a lower rate, like you only getting network input at 20 frames per second. You start interpolating these things. So you could just always interpolate. You could just always have everything interpolated. On the other hand, if what you're making is an esport, you really just want everything to be updated as fast as possible, and interpolation adds some artificial. So this is just not getting stuck. Okay, so let me switch it back. Where is it? So let's switch this back to being the server and see if this is actually consistent, that this is only outside the debugger. Okay, so I'm reading the replies to that stuff that I was saying where I was only half paying attention to what I was saying, so I may have misspoken to you. Okay, so yeah, if you really want to annotate something, when I was rewatching the last episode, there's a nice rant about why I think sizeof and size-t should be signed. Which may not be something that everyone believes, but it's a well-formed. I was rewatching it. I was like, oh, I should really say this, and then I said it, and so I think it was a properly done rant. So if you care about that kind of thing, okay. Now, oh right, I need to ram trees because that seemed to be related. Maybe it's only this one spot. Maybe it always had to be there, and so I was never going back to this. I don't know. I can't make it happen again. It happened twice, and now I can't make it happen. Maybe it had to do with the jumping. I had to jump in the wrong spot. Well, what episode was that? The size-t rant was in the very previous episode on YouTube. Oh, some key got stuck, and I was moving. Yep, okay, so I got stuck, and it made me run over here. All right, so it definitely happened. So let's reverse it again and see if I can make it happen in the debugger. And if I can't make it happen in the debugger, goddamn. Oh, forgot to do that again. Let's restart the server just to make sure that didn't mess things up. So it's somewhere in it's a 2 hour and 50-minute episode, and I started watching at 2:05, 2:10, something like that. And the rant is probably at least 2 minutes long. So if you just skip along once, and listen to a minute every minute or so, starting at about 2 hours into that episode, hopefully you could find it pretty fast. It was just me replying to a question from comments, so it didn't have anything to do with what I was coding. I mean, it did, because you can look for where I hit a bunch of warnings because the signed to unsigned comparison, when I'm comparing a bunch of stuff, adding size t to a pointer, to an offset. I have an offset and a size of some struct, and I'm comparing that to a limit. Oh, I just fell through the world. That was another thing that was happening in the old last episode when I ended. But that's a different thing. Like, I've moved too far away and the server is screwed up in some way or something. So it's not what I was looking to test here. What I'm looking to test here, I don't want to have two clients because that's already broken. I fell so far that it broke the... Oh, now I hit that SDL bug. Let's try running the server again, run the client again. Last try to get stuck in the debugger. That was all. I have no idea. Maybe it was 5 minutes, not 2 minutes, right? It's at least 2 minutes. So when you're looking for it, so yeah, I guess let's just get to the physics programming here. I'll try this a little bit more, and I think I will start to remove some of the complexity that is making everything messier. And then the first priority will, I think, be, I kind of need to walk through some of the stuff that I'm not sure what I was doing, like how the authoritative view stuff works. I could rewatch many hours of video to find out, and that would take forever. So it's faster for me to just look back at the code and figure out what's going on. Did I just get stuck? Oh, no, I eventually fell. Am I going down when I jump, or am I going up when I jump? I don't know. I think it's going up when I jump. But I never, I'm facing uphill when it jumps, but I never add to DZ, so I don't know how that can happen. Just, boom. unless it's only happening on the client. Maybe the server doesn't actually know. Look at that. I'm colliding with where I am. So it's clearly happening on the server. Something is giving my Z a big positive, my velocity, Z velocity, a big positive bump, and I just don't know what it is. These textures aren't that bad. I was really critical of them, I remember. And for what they are, like, they're not really supposed to be voxel textures. And they're like ancient low-res textures, so, you know, they're not super high-res. They're way high-res than like a Minecraft. They look full-res here because I don't let you get that close to them, but they're probably okay. I mean, these are like wood planks. They're not really tree trunks, but whatever. Yep, I don't know. I can't make it happen. I'm going to follow the world soon if I get too far from the origin, I think. Now, if you note for your annotator, in the very previous episode to this one, does the annotator know what episode this one is? Oh, I see. You're just grabbing it out of the log. Okay. So you'll know which thing it's logged for. All right. Well, it's not happening. So apparently it's a bug that only happens outside the debugger. Hooray. And it requires networking. So what a mess. Why does this never show the DOS prompt when I break it? Oh, because it's not breaking. It is auto climbing. It's just supposed to only auto climb by 1 block at most, and it does not change the Z velocity. So you can see the ZDZ stuff here. This never plays with velocity Z. It's not supposed to. It can zero the velocities, but it's not supposed to ever do anything to velocities other than zero them. For some reason, that's the logic here. So nothing in here should ever set the velocity except to 0. And then the caller, we negatively add, we subtract from the velocity because positive Z is upwards. So to accelerate downwards, we subtract. So here's the only place where the velocity is supposed to change other than zeroing. Here's a place where the velocity changes, but this is a friction. Vel is positive. Let's just assert new vel over vel is greater than or equal to 0. So as long as you never multiply by negative, then the velocity shouldn't be able to. I mean, it should always be. Well, it always zeroes it if it goes past. I'm just wondering, does it? It's deceleration. That's what that's short for. Yeah. Okay, right. So yeah, you should never be able to speed up from this, and that's true because this is vel is positive. This is positive. So this, your new velocity. This number is always positive. You're subtracting it. So this always is smaller than vel. So, which means that this is that. So you never can speed up. So if you had a positive velocity somehow, it should never be able to get increased by this. This can never create a positive velocity if you don't already have one. And this thing should never be touching vel Z except to zero it. Yep. And then we don't take velocities from the client. We take inputs from the client and simulate those inputs. So there should not be any way for that to happen. What is this doing? Rolled thrust. That is the player input. Oh, wait, there is a button to make you go up? Wait, what? Ooh, there is a button to make you move up. I didn't remember there's a button. I thought that's only if you're not flying, but it is always doing it. Look at that right there. Yeah, and then it adds to it here. And I search for a velocity.z, but look, I'm using this, treating it as an array, so there's no .z. So it must be coming from those. So maybe there's a network error that causes it to press this jump that I didn't even remember existed. Let's see if we can figure out what that is. Buttons or equals 16, maybe? It's going to be a Mac. Well, why are these? Okay, where are these coming from? Player controls, which then come from the net controls. I was looking at that code at the end of the last video. It did this unpack the buttons here. Client player input buttons. Well, it's what we're showing actually. It was what we were seeing in the debug output, the info. Oh, that's only on the server. So the question is, were either of those bits getting set? Oh yeah, and maybe they were, and I just wasn't catching it. So, but why do those buttons even exist? I guess I just put them in. Oh, they need to exist so you can fly. Okay, wait, let's look at the, like, this is a total rat hole, kind of, but let's look at the flying logic. So that's probably in main where the input handling happens. Been a while. Oh, hey, look, have some old. Here we go, active control set. So space and left control. Right, well, there's the Minecraft flying thing. So client player input flying. Do we transmit that across, or is that still just a local only hack? Yeah, we send that all across, so we actually get the flying flag. So there's a cheat mode to turn on flying. And then do we check it anywhere? Here's somewhere else we force it. Well, we force it on at the start. Do I have flying enabled and I forgot? I probably do. Oh, there's no server, so that doesn't work. Oops. That's amazing if I have this and I've just forgotten it. Okay, but it's still applying gravity, which prevents it from working, I think. Oh, right, it has that. So wait, why is but we set it to true. I know I'm stuck because this isn't handling multiple clients properly. Oh, what is going on here? Let's see. So flying is either F or Control F. That seems to have wedged me. Nope, now it's still just doing that. Are we sending that across? We are sending it across, but then how does it get? Oh, I'm so confused. It wasn't in server, it was in world. Player physics, player controls. Right, but we send across player net controls, not player controls. Network, player net controls. We are not preserving flying. So the flying hack is not being passed across. So that just doesn't work. So it can't be the flying hack. But we can check that because we can make sure that we never hit the flying case, which is this case. Well, we had one running already. All right, so here we are on the client. Let's move around. There's a little jump, and it did not trigger. And I don't see the buttons change. Oh, nope. Button's 85 for a second. Maybe that is related somehow. Oh, I looked away. Didn't see whether it triggered. I guess I could actually stop and look at the scroll back. Oh, and I got wedged. Nope. I just that's a nope. And now I'm accelerating in the wrong direction. Also behaving normally. I could get wedged at this point. I'm surprised I haven't. It's being super laggy though. All right. So I don't know what's going on with a lot of this stuff. Okay, it's clearly not that. So I don't know where the jumping is coming from. Which axis was up and down? Z is the up and down axis. Can blocks be destroyed? Not yet. How many milliseconds is the voxel polygon meshing? So that might get faster with the other stuff. I don't remember the times. We'd have to look at the old videos. This is on a fast computer. It's using multiple threads to do the voxel polygon meshing. If you look at the SCP voxel render, I'm able to fly fairly fast around a Minecraft world with a very big viewed radius, like 1280. So the largest you can set it to in Minecraft is 512, I think. It's 16 chunks. No, wait, 32 chunks. And each chunk is 16 voxels, so it's 512. So rates of 512. And you can set it to rates of, it was, I think, yeah, I think it was 1280. I don't know why that was the number. And it mostly was able to keep up flying around pretty fast. So it was fast enough. But I don't remember how many milliseconds it is per voxel, you know, effectively or whatever. Microseconds, whatever. That is certainly all of what the SCP voxel render is about, is trying to be reasonably efficient at that. From a full 3D solid representation, you know, of a 3D array. All right, so I don't know what's causing this jumping. I just spent a little time trying to investigate how it could ever happen and couldn't figure it out. And the whole time I'm doing this, I'm having this terrible latency of the input. So let's go ahead and just have us always use the most recent input instead of all this crazy logic. When we receive packet, we're updating. Are we just directly updating? Oh, this is a client receiving packets, right? So when the server receives a packet, so when the server receives a packet, process player input. And then, right, I was just reading this. And then this is doing 2 steps, consume 1 input from each player input key. So let's have the consume the player input, copy from input 0, but not overwrite it. Let's F0 this. And then up here, let's change all of this logic so that it simply says history of PID dot client, no, input of 0. It's whatever one we just used here. Input 0. With input of last inputs? What the hell is that? Why is it sub I? Oh, inputs per packet. So we just want the first one. And return. So let's just always have stored the most recent packet we got. And since it's UDP, we shouldn't actually miss packets. It should all be going fast enough, in theory. And yeah, the lag is a little better because we're no longer trying to do this buffered thing because we don't have the client-side prediction yet to hide it. So it felt really wonky. Now, it can miss inputs, but it's okay when I'm mostly just holding stuff down. It's not a big deal. And we still have the jump bug. Okay, good. All right, so that feels less wonky. Still have to solve all that problem, but it gets around that. Can blocks be destroyed? Yeah, so that, I started to answer that. None of that code is written yet. It is totally possible. You just have to remesh the thing. So you've got to, I have to add logic to set a flag to remesh things and decide how rapidly do it. That's one of the things that Minecraft can get sluggish about. So I want to be a little smarter about it, maybe than Minecraft is. I don't know how smart Minecraft is about it. You know, when you have you know, a bunch of people working in the same chunk, so you just keep rebuilding that chunk over and over and over constantly. It might be smarter to do something where you don't rebuild the chunk. If they're building stuff, you just draw the new stuff that they've added without meshing it, or you just do it latent, batch up other people's changes and apply them all at once instead of piecemeal. Certainly, like if in Minecraft, you know, when you're hitting a thing to destroy it and you see the successive destroyed states, if each one of those required you to remesh the whole thing, that would be kind of crazy, and I don't know how Minecraft does that. Is the data set available so we can run this offline? So the stp voxel render.h has several different things in that video. One of the things in it is some Minecraft stuff. The Minecraft stuff is all publicly downloadable levels. It gives the name in the trailer, the name of the level at the bottom right. And the program that is running to do that is called KView, and it is on the GitHub. I have never tried to build it outside VC6, so some work might have to be done to build it. But that is like these big cities with the view radius set to 1280. That all should work. The other stuff that I did were some other demos that I'd never put online. I kept modifying the same program, so they don't. Those data sets don't exist anymore. They probably didn't even get archived in source control. Okay, so. Oh, excuse me. I was going to say, this is towards the end of my day. Oh yeah, and the administrative detail I forgot at the very, very beginning I meant to say is there is construction going on outside, so if you're hearing crazy noises, that's why. And maybe you're not, because I have a good mic. So yeah, I'm kind of at the end of my day. I've been up for a long time. So I may bail on this soonish, not yet, but just because I don't want to keep trying to work if I don't feel like I'm being effective anymore. I don't want to put in more bugs than I'm finding. So that's just a warning that might go this way. Let's go ahead and make this explicit so I don't get confused later and do this. Excuse me. Gotta put those inside. All right. So let's go ahead and if def no player input buffering. And then we do the same thing here. Where was it that we were doing that? What was the other thing I changed to make this work? Oh, this. All right. So that takes out all the worry about the synchronizing clocks and all that mess. Physics that only works around the origin at the moment. It's just because of the network side of things. The physics was working fine before I put in the networking. Something has broken and I don't know what. It's a thing to. It's another of the many bugs I have to debug in the networking. It shouldn't have changed. Like the server. I don't even remember what I did to make the server keep track of what needs to get loaded. Maybe I haven't done that work. So one of the things that happens is in the engine for the client, you just build the terrain around the player to some distance. And it doesn't really matter if it's there or not because you render it or not. The only thing you really need for the physics is immediately around you. For the server, it's going to need to keep the area around multiple clients. They can all be in totally different areas of the world. They can all be in the same area of the world. So it's a little complicated. And I don't remember if I did any of the work for that at this point. So maybe that is the problem. Maybe the problem is that it's trying to only build the terrain on the server around the player or around not the player. And maybe the player is just going outside of the area that's built around the origin or something like that on the server. I don't remember what the status of any of that was. So I'm just not worrying about that yet. Like I can tell there's a bug when I go outside a certain distance. So I'm just not going outside that distance because there are so many other bugs. Yeah, and the construction noise is much quieter than it was when I was just starting the test stream. There's some machines that when they back up have a really loud beeping, and that's the biggest noise that's actually happening. There's no actual like jackhammering or anything. Excuse me again. So we're just ignoring all that timing stuff, which is great. That's a huge mess that I don't know how to solve. And so what are the bugs that I need to address now that it's not latent? Let me look at this again. Other than the jumping thing, is there anything else? Now the big problem is I no longer have, since I put this in a server, and then I think they run on the same port, so I don't trust it. So obviously this is the jumping bug. The latency is all fixed because I turned off the timestamping. Yeah, it all feels fine. Feels super immediate. But not quite 100% immediate. It's still got a weird... Yeah, it's a bit out of phase. But that's also because I have smoothing on this. It's not... do I have smoothing on it? I definitely used to have smoothing so I could make these nice smooth demos. Don't remember if this version has the smoothing. Feels like it has smoothing on it. Like when I drag and stop, it keeps going for a while. That's got to be a physics sim on the view. Let's take that off so that that's not introducing some more latency. Where would that stuff be? It's authoritative on the client, so I don't even know where that is. Pending view, it's all this stuff. Oh yeah, client view physics. Yeah, I update the angular velocity with that. So let's try. It's all total tangent, but wait, are those actually deltas? I assume they are. But I zero them here. Yeah, that may not really work. I don't really know how. I need to go look at how that's being used. Oh, right, I have to run two. Nope, that's still doing some kind of physics. right, let's look at pending view X. Okay, so we take our DXs and we subtract from the... So those become positions. And so then we're taking in positions, and that should just stop them. Oh, but the client thinks it's flying. So I turned on the flying in here somewhere. Player, where was that? What was it called? Flying, player, client, mode, flying, player, client, input. What was it called? Client, player, input. Yeah. Flying equals true. Yeah, it was somewhere here. I don't know why that was set. Okay, there we go. It's solidly locked to my motion. I think that is because it is being done on the client, in fact. Because that physics sim on it was only running on the client, in fact. So, and it seemed to be authoritative. So it's terrible. It's weirdly jerky and bad feeling right now, but that might just be because the proportions are bad. In fact, hey, look, let's just use the same multipliers we have there. What was this question? Why the dt times 60? Where? Where was the dt times 60? Up there. It's just a tuning number that made things feel good. Or the input coordinates here. Input coordinates here are just an arbitrary. No, this is just an arbitrary scale factor on the mouse coordinates. Already just an arbitrary scale factor, so it's just another arbitrary scale factor. Yeah, it's not like 60 frames per second, I don't think. It might be. Maybe I had a version, maybe this came from an app that ran at a 60 frames per second tick. Or something, like, I don't know, maybe. What? I closed it. Oh, I never built it after closing it. Yeah, that feels reasonable. It's not perfect, but it doesn't have any mouse acceleration or something, maybe. So it's not quite right, but it's so unsmooth. I'm so used to the super smooth motion. That this just feels really jerky, but hey, welcome to first-person shooters. Why is it not letting me go forward faster? Why is it not? Oh, it got stuck. It's stuck with, oh, it's just latent. What happened to the, I thought I turned off the latency problems. That was weird. It's not being latent most of the time. I mean, it's being a little slow to respond because of the physics. It's applying an acceleration, so sometimes it's slow to reply. But anyway, the turning, though, is perfect. Okay, so that all just feels better. So when I'm testing, life will be less terrible. Now, am I no longer jumping? Did changing that? Nope, there's a jump. Okay. That was weird pause in midair. Is that because I collide with something? Yeah, probably. So one thing that might be happening right now is I collide with stuff, but I'm not turning off the velocities in other directions, and so then it keeps trying to tunnel into the same thing. So let's go back to that thing I changed in the physics and check what's going on with the velocities. So what I decided to do is turn off the sideways movement. In terms of, I look, where is the furthest I'm allowed to go without colliding? And we assign back to the, so there's a weird thing here, which is that we verify that we're not colliding. Oh, we verified again here. Okay. So the whole point of this epsilon thing was to try to make sure we don't overlap different, because I didn't quite explain what was going on here when I did this. I'm trying to snap in this case, the top of the guy to the top of the voxels, and in this case, the bottom of the player to the bottom, of the player to the top of the voxel, and here the top of the player to the bottom of the voxel. And that snap, it's supposed to not move the player into any new voxels that they're not already in. It just moves them up within whichever voxel. Like, they're across multiple voxels, but it moves them to the top. And so, if they're not colliding in the old position, they shouldn't be colliding in the new position because they're not supposed to overlap any different voxels. So that's what that stuff is doing. And then because I know we only get to this code, they're not supposed to be inside any voxels to begin with. So this assertion is about what was true the previous frame, was saying they didn't end up in a voxel the previous frame. Assuming they didn't end up in a voxel in the previous frame, we update their Z position to try to snap in that way it said, and then we verify that they're still not overlapping any voxels because we shouldn't have crossed any voxels when we did that update. So that's what was going on in that code that I already explained. All right. So what was I just doing? I'd rat hole into that. Right, I was just trying to get all the latency issues away so that it felt better, but mainly because so this is the second player, which is maybe broken. Yeah, I'm inside something at this point. It used to work to have multiple players. I just have broken that again as I change things. All right, so fixed all the latency. So now we're looking for more bugs, networking bugs. We'll try to bring a second player in a little bit, but it seems like the jumping is the priority because what the heck is making that jumping happen? So what we want to do is find where Z is going greater, velocity is going greater than 0. So where's our velocity? Which player ID are we getting? Come on, why can't I tap it? There we go. Jeez. There's a packet that tells us which player ID we are. We unpack the packets. Here we are. Player ID, right there. Okay, we're ID number 1. That will actually be true on the server. Every time we run it, it's consistent. So now we can run the client on this side and the server on this side. And we know we want player ID is 1, which is the obj ID also. So then we can just look at, so let's just do this. Let's use a data breakpoint. Although that might be slow. That's the client. We want the server. Here we go. Wait, why is it saying object 0 is valid? Oh, that's that hack. Wait, why is that hack on the server? That was a client hack. That's the old client hack for knowing what our obj ID is. We would stuff it in that. Oh, we'd stuff it in that in the server and then send it across. So that's just old bit code, I believe. And if it weren't networking, I would test. But it's not working, so I'm too lazy to test. So, because ob0 is never valid in this engine. So that field was free and was easy to send across the net at the time. All right, so what we want to do is wait until we get a valid player. Right, okay. Okay, so now we run the player, and we should get a valid player. Okay, now we got a valid player, and we want to look at object1, should be the player. Okay, and we want velocity.z, and it's negative, so it's falling at the moment. So what we want to do is edit. So let's take the address of object1.velocity.z. There we go. Edit breakpoint data. So we want to catch changes in this address. Except that will catch everything. We want to actually only catch it when it becomes positive. So we'd like to I don't know. Can we set a conditional breakpoint on a data breakpoint? Can I make a more complicated expression here? No, I don't think so. That's just the expression. If I try to make a more complicated expression, who knows what it's going to do? Well, we can try it. Let's try it. It's greater than 0. Let's see what happens. I've never tried to use a conditional breakpoint in this thing. It might be too slow. It might not be. All right, so we run around. Can we run around? I can't move. Is it running? Is the server running really slowly? It might be. Because this is just the client having authoritative thing. Yeah, it's probably the server is running incredibly slowly. Oh, or it hit it. Oh, it did hit this case. World thrust 2. So that's because thrust of 2. No. So where did thrust of 2 is still 0. Where did world thrust? Is that uninitialized? Oh no, it's from this. Oh, you can tilt up and get upward thrust. All right. I don't know if this has anything to do with it, but if con of flying world thrust of 2 equals 0. Let's just see if that helps. Oh, I gotta run this server first. Oh, that is the server. All right. So I was looking up when I hit the thing. Oh, now it's going backwards. It's going backwards when I look up. What is going on? Why does looking up make it go backwards? What? Why would changing the world thrust of Z reverse that if I'm looking up? That's really weird. Why would that be backwards? I don't really understand. Did anybody else catch a bug? No. How does that break thrusting on the X and Y axes? What? I wasn't just imagining that. Wait, that was, well, Jesus. That is the thing I changed that caused that. Oh, what was that? I deleted that valid. Maybe it was that valid thing. Maybe I'm still relying on that hack somewhere. Oops, wrong one. Oh, that broke again. Breakpoints, breakpoints. Nope, it's backwards again. Okay, so maybe that obj valid thing was actually still being used for this. Maybe I haven't actually set up those packets correctly. Is that in network? Yep. Right. See what happens when you don't test your changes? No, that has nothing to do with it. There's some other. Don't know when I would have made the change that broke this. Maybe I never look up. Maybe I haven't been looking up when I drive around, so just never noticed it. But how could you get that wrong? Base thrusts are in the right direction. How does looking just barely up tilt that in the wrong direction? What about sidestepping? Sidestepping doesn't care. So the question here is about why the moving backwards is happening, and it has nothing to do with the issue. It has nothing to do with the case that's breaking, and I haven't been very explicit about the case that's breaking, and that's because I would need to draw an illustration to really explain it. But you have a forward vector, and your forward vector is tilted by your orientation, reoriented by your orientation to be the direction you're trying to walk, and then it needs to ignore the z-axis of that because you're walking, except if you're flying. And so that was that change that I made. The thing is that if you tilt, your walk direction is along your forward facing, and if you think about your up vector, when you're tilted down, your up vector points forward, and when you tilt up, your up vector points just slightly backwards, right? When I say forward and backwards, I just mean, your up vector is up. You tilt forward a little bit. Here's a person. You tilt forward a little bit, and your up vector now points forward just a little bit. You lean back a little bit, now your up vector extends backwards just a little bit. So it's like it's moving in the direction of the up vector instead of the facing vector. However, I wouldn't think you would get enough speed doing that unless it renormalizes it. I renormalize. Burp. No, I don't. I use apply friction. But maybe there's just been a bug there all along. Maybe the object space to world space is doing the wrong thing. Thrust 0, thrust 1. It takes the two. Oh, it's passing those in as an explicit vector. Wait, that takes. Oh, I see. Yeah. Right. So it's just doing this vector rotation, but maybe it's doing the wrong set of rotations here. Why would it? Yeah, a trick bug. Oops, ran the wrong one again. That seems unlikely because then it would just. It seems like that would break in a different way. So, for example, I would go faster if I were looking straight down than if I'm looking nearly level. Maybe I do. Maybe I do go faster. So yeah, maybe it's just a trig bug with the wrong rotation matrix. So you passed in the x, y, z vectors. It turns it into a vector. It applies a x and a z. And x is rotating around the x, and z is rotating around the z. It would be easy to have these backwards, but that wouldn't cause this behavior. That would cause your rotation angle to be reversed. It wouldn't cause you to be along the wrong axis. We want C to be times 1 and 1, 2 and 2, C 0, 0, C 1 and 1. Right. The problem is I'm not passing in the up vector. Like if I passed in the up vector, you would expect that behavior. I'm passing in this, and 0. And this is the up angle. Maybe the view angles are getting scrambled when they're communicated across the wire. Oh, I changed I changed this. So maybe that new logic introduces some other bug. Nope, it's still happening with this. Yep, okay. Yeah, it's like I'm rotating the up vector, which would explain that big upwards burst, but I'm not rotating the up vector. Where is that again? It's in world. Player physics, on space or world space. World thrust, which should be, yeah, but I don't pass in thruster 2. I just pass in this. All right, well, let's simplify it. So I should be just always walking, shouldn't I? I'm not moving at all. Shouldn't it just always be moving? What? Oh, maybe this number is too small. Maybe the units I'm using are much bigger. I don't know what they are. Effective acceleration. What's an acceleration? Not a velocity. Yeah. Acceleration of 6. 9. Effective acceleration is 9. Maybe the friction is so high that that was being prevented from ever moving. Nope. Okay, there we go. So I'm always moving to the right, whichever way I look. And if I look up and down, it doesn't make any difference. Okay, so that's good. 1 is rightwards movement. Okay, so then we go 0,9. So that's on the y-axis, which is by default how the camera faces. And now we're always trying to move forward or backward. And there's a big giant leap. Okay, so first of all, yeah, if we do this, we could probably force the leap to stop happening. So the problem is that this axis is getting handled wrong for x rotation. X rotation, vec 1. Looks good to me. Cam X, Cam Y, Cam Z. T0, T1, T2. Ang X, Ang Z. I don't see any issues here. When you're nearly level, when Ang X is at 0, Maybe its rendering is 90-degree rotated from what these are? These are interpreting what 0 is as differently from that? Seems unlikely. Where does the rendering happen? I don't remember. Where does rendering happen? Is there a client function? Third person, we could test that if that were still working, which I don't know if it is. Oh, we use GL, so but I mean, it's got to be this. I just don't see how. Okay, so yeah, let's. Okay, this is the server. Let's go ahead and breakpoint and see what value that has when I'm looking level. All right, I'm looking level. Looking just slightly backward. Okay. There's the giant jump. Burp. Okay, so cam x 0, cam y 9, cam c 0. Angle x 90 degrees, not 0 degrees. Oh, well, wait, 90. This isn't even degrees. This is in. Oh, no, it isn't degrees. Okay. 90. Why is x 90 what it takes to have a level view? That ain't right. That was in main. Do we do an initial init camera Z up facing Y? Is that broken? What do we initialize? The camera ang. Cam ang doesn't get initialized. Where does that get initialized from? That's why it's cam ang. What was it called? Cam ang, one word. Right, it comes from that. So what does that get initialized to? So when we create an object, I guess it's done in physics? I don't know, network? Who creates the object? It's when the server discovers a new client, right? Create connection. Probably creates a new player object. What does it do with the other stuff? Allocate player. Does allocate player 0 it? Okay, here we are. Allocate player. We don't even initialize it. That's pretty dumb. But of course, the client is authoritative about. Maybe it's not currently authoritative. So I don't know. Maybe this was. This is supposed to be in init world. This is supposed to be in allocate player. Or whoever was calling allocate player, I guess. Yeah, I don't really want to do it right here. Well, maybe I should. Yeah, we used to initialize and set that position. Now we do this. We create the player up, player high, and drop them down. And let's change player ID to PID. Now, I don't know how the client authoritative thing works, so this may not fix it until I fix that. Nope, it's still... Oh, I hadn't changed how the... If there's a difference between the two, I haven't fixed it. I just changed the initial value. Right. It did start level. Like, the view started level, which it might not... I think in the past it might have started looking down or something. So I maybe fixed something there. Or maybe not if it's still client authoritative. So how does that happen in this network client? X and Y. Oh, that's saving out. Right, this was the thing where we used to be stuffing 0, and I changed that at the beginning. So maybe that was breaking it. No, still the same behavior. And this, even if I put that back, that would still be a bug. So, okay, so here, when we render, we copied out the object. We zero it when we create it. Angle from network. So that's the server. Gets it from the player and updates the server's opinion of it from the player. And the server writes it back out. What? What? What is that? What is that right there? Why are we... Oh, it forces it to be positive. And it's supposed to subtract it back out here to restore it. But then when we decode it on the server, we never subtract out the 90. There you go. We have this this undocumented hack that the point of it is that we actually want to constrain your vertical tilt to go from positive 90 to negative 90, or positive 90, whichever one it is. And I'm actually only clamping it to 360 here, not to 180. And that's because some other code is supposed to do this. The only thing this is doing, this isn't updating the object. It's just for the network send. So for the network send, it tries to push it into the range 0 to 180. And then forces it to absolutely be in the range 0 to 360 just in case. And it doesn't angle the network encode, which is a fixed point thing or something that I don't even remember what it is anymore. Yeah, it seems it's 360 range. Now, of course, there's no reason to do that negative 90 offset exactly, except that we would like it to stay negative 90 to 90, and the 360 thing forces it to be always positive. And so just for consistency, I was trying to temporarily force it to the 0 to 180 range and then restore it back to the old range. And we do actually write it back into the player object. This is so that this quantizes the angles, and so we write it back to the player object so that it remains quantized on the player, so that the player and the server have a consistent view of what the player's orientation is. So like when the player runs player-side physics, it's consistent. So we just need to subtract that out when we decode it. So client build input, and then the server decodes client input somewhere. That's post-physics, so it's pre-physics. Net receive, do this processing. Angle from network, minus 90. All right, so that'll fix that bug. And notice I didn't comment it still. Okay, now the hard-coded motion is, I added to the wrong one. Did anybody catch that? I added it to the wrong one. Let's go back and check. Where is that happening? Yeah, it's X, not Z. Okay, there we go. Now I'm being forced to move forward, and I got stuck against this thing. Okay, yeah. So the being forced to move forward, it seems to be working. And now if I tilt up, yep, it's still correct. All right. So now let's back out all those bad changes. So what were the bad changes? 0. We can turn that back on now because that'll fix this. Oh, here it is. I'll do a git diff and make sure I didn't miss anything. There'll be some other changes that are legit. Oops, not in the right place. So we initialize thing, which is what we're doing. The input buffering. Fix that. There's some spaces there now. Some space. I fixed that bug. Change those numbers. Change that. Physics. Sure. All right. So the question is, does that fix the jumping up problem? Was the jumping up being caused by that somehow? And we will see. Oh, I go a lot faster now because the vector is pointing in the right direction. So I need to retune those numbers. And it's probably time to go ahead and add the physics to push along walls because getting stuck against this stuff really sucks. Yeah, I'm not jumping anymore. Hooray. I think that was that bug. So when you do little hacks like that, you gotta figure out a way to do it in a way that's safe instead of hacky. And it's still the hacky way right now. So I need to find a way to write that logic that's less ambiguous. Like that has an explicit sort of like preconditioned, okay, I went out of that 0 area. That has sort of an explicit precondition the inputs and then postcondition the inputs, and then you run the same postcondition the inputs on the server afterwards. Or just explicitly unpack. I guess if it was part of unpacking, which is sort of the same idea, it would be more consistent. I do not use Git in general. I use Git for FTP stuff because it's publicly developed. It lets people submit pull requests on GitHub. So I only use Git because of GitHub. And so then OBBG is also being developed as an open source thing. And so even though I'm not taking pull requests right now, well, I do take them but we're not expecting people to put in features. But if people do ports or something like that, I can take pull requests. So it's, again, just to have it on GitHub. So, okay, I fixed several bugs. Haven't really addressed any of the networking stuff, although that was a networking bug, in fact. And I've been streaming for 2 hours, so I think I might stop, even though I haven't really done anything substantial networking-wise, because I am a little tired, and although I don't really want to sleep, so maybe I should force myself to stay with it. I don't know, when was the handmade thing? Did that already start? Did that start 45 minutes ago or something? So at least I'll check in. Certainly I should do that to start with. I still have that. I turned that back on. Let's like that. It's not if zero anymore. Leave all those asserts in. This hack I do want to keep. This probably will become the legit code because this is the whole smoothing thing was. The smoothing thing was this crazy physics on the view was so that when I made the SP voxel render demo, the motion as you were flying around was smooth to make the trailer look better. Single player will probably be done as callbacks to the server code. It might not even really work that way. I might just let them sort of have two different main loops and handle stuff. So like, one of the things is that maybe that's not true. So one of the things I have to address is that the design is that typically you'll procedural gen your train. You could still do a Minecraft style engine with it's baked to disk. It's procedural generated then baked to disk. You will need some kind of baking to disk to allow people to change it. But what I'd like to do is have it be proc gen even though it's that you can make changes to it. In the sense that like maybe if you haven't made any changes to it, it still gets proc gen. In Minecraft, once it's procedural generated once, then it just always loads it from the disk. And that allows the procedural generator to be slow. But the problem with the procedural generator being slow is you move around through the Minecraft world for the first time and stuff is kind of terrible. If you've ever seen Minecraft UHC, Minecraft UHC, but probably other UHCs, when they do a random terrain and they spawn 12 people at random places in the server, now the server is sitting there generating the terrain for around all 12 people and then sending it to the clients. And that's all pretty slow. So the intention for how OBBG can work is that the clients can generate the terrain as well. And the server just has to send them the diffs of what people have changed. And so you don't have to save the full terrain to the disk, you just save what the deltas are. And so for that to work as you run around through the world, the proc gen has to be fast. Now, what was the question? Oh yeah, so when you're doing networking, the player needs to generate terrain around the player's view, say, you know, out 1,000 blocks or whatever, and cache all that. The server needs to cache enough for physics. So say that, you know, mobs are only active 100 blocks around players, so you need to keep around 100 by 100 radius around each player. So you have to have all these different sort of sparse things, but you only need physics info for them. You don't need full rendering info for them, although those may just be the same thing. It may not be worth trying to distinguish. Like physics, you could have like a bit per voxel or something and have a much more compact representation. But if your physics has slopes or half blocks that affect the physics, if your engine has those types of blocks that affects the physics, or, you know, you want people to be able to, you know, mine or whatever, so you need to know what type the block is, not just is it solid or not. You still need all the info, so the physics may do it. Anyway, the point is if you just run both of those, the server and the client, I've talked about this in past streams, if you just run both the physics and the client in the same process, they're going to both independently be trying to do this procedural generation, and you're doing twice as much procedural generation as you'd want to. So you actually want, when they're both running, to do something smarter in terms of your proc gen and sharing that database between the physics and the client, even though when they're running separately in multiplayer mode, they are different kinds of databases. So you want them to turn into the same database. And database here is just a fuzzy word, right? I just mean the cached map data. So you have to actually be a little smarter about single player there if you want it to be efficient. And this is that's the handmade style, right? Like, I don't want to have it proc generating everything twice. It wouldn't be everything because the physics around the player is a smaller one. It's only would be generating this little local radius around them. And in fact, that's already kind of a weird thing. In rendering, we generate all the way out this huge radius, but we don't store that as the full 3D block data. We just store that, we mesh it and leave it as a mesh, and we don't actually have to keep around the 3D data. But we need the 3D data for the physics, and maybe it's better to regenerate it just right around the player, because when you're generating like a 1200 block radius, I don't remember what the block size is in this, but let's say it were 64 just for the sake of argument. So 1280 would be 64 times 20. And if you just imagine it was square, that would be 40 times 40. So 1600 blocks you would be generating. And you don't want to store the full 3D cube of 1600 blocks. It's too big. But if you think about when you're walking along, like moving at high speed, every time you cross a new chunk, there's a horizon of 40 chunks that have to get built, because you have this big 40 by 40 grid being maintained, and each time you move along and it crosses the next chunk, you have 40 blocks to generate. That's fine. They generate in threads over time, and it's just outside your view distance, so the fact that they come in staggered is fine. But you're generating 40 of them. For the physics, you only need a tight region around you, so say a 3 by 3. And so every time you step a chunk, you only need to generate 3 things. So maybe it would be okay to just keep the databases separate, and the rendering will be generating 40 chunks every time you cross a chunk boundary, and the physics generates 3 chunks every time you cross a chunk boundary. And so that physics generation is so small compared to the rendering that who cares? Like, that cost isn't worth getting rid of, maybe. The difference between, if both of them cost 40, generating twice as much data would be pretty efficient. But if one's 40 and one's 3, maybe you can afford the cost of generating the extra 3 all the time. And then you don't have to store all that other data. If you try to share them, you actually need to store all of that data and never regenerate it, which you'd have to compress the full 3D array representation down to run lengths or something that was less memory intensive. Probably. I haven't done the math. Optimal chunk size is based on player max speed. Not exactly. The chunk size, the max speed determines how many voxels, the combination of the player speed and the view radius determines how many voxels become visible every second, right? As you move n voxels per second, a horizon's worth of n voxels becomes visible. The chunking just determines how that gets blocked up into blocks, and so the actual chunk size itself doesn't matter, but how far out that radius matters. And the point that I was making was that the radius for the physics is much smaller than the radius for the rendering, and so maybe the cost of doing the physics doesn't actually add up the same. However, both of those costs are quantized to chunks instead of being actual voxels, but you can just think of it in terms of the voxels. Is a 3 by 3 physics boundary going to be sufficient? It's 3 by 3 chunks that I was saying were 64, and I don't even know what my chunk size is. 3 by 3 is just the minimum of what you can do so that when you step, you have stuff available. Yeah, so mesh chunks, is that the right term? Because there's all these different freaking types. Yes, mesh chunk is. So I did 64 by 64. Well, so it depends on your game. I would actually like to support long-range snipery kind of stuff where now you need physics over a much larger region, and then these arguments do start to apply again. If a block is a foot instead of being a meter like in Minecraft, if a block is a foot, and you can see, and your view radius were still limited to 2,000. That's not very far. 2,000 feet is what? 600 yards? 600 meters, ballpark. Like, not really, but whatever. Yeah, you could shoot 600 yards, so you could shoot all the way to the horizon, I guess, with the right kind of gun. MMH. Is MMH a person that you're talking to? So yeah, in plenty of games like Minecraft, you can in fact move faster generation, and the goal, one of the things I'd like to do in that attention to detail quality kind of way, is design it so that you can make games you can take OBG potentially, right? We don't even know what OBBG is, but you can potentially take OBBG and make anything with it. But it will be designed for the sweet spot that you can get motion as fast as we can make it with a reasonably sized view radius and not outrun procgen. That's the goal. Whether it's achievable or not, I have no idea. I mean, it's achievable if you set those numbers small enough. But so that's a trade-off. Like, well, if you are limited by running speed, like your view radius is going to be limited by several things, right? The GPU, the procgen rate, and memory. So the memory, voxel render does a decent job of getting it down. I think it's 10 bytes per triangle is the current thing, which means it's 20 bytes per voxel face. And you can look at the numbers for what that turns out to be in the Minecraft city demos. Now, so that the problem is that given a fixed view radius, the number of quads, triangles visible is super dependent on the complexity of the scene. You can start doing the occlusion stuff that Minecraft tries to do, but it only works inconsistently. Like, it works okay for their caves, it doesn't work on those cities. So it's, you know, it's a game design trade-off as well. No planning on doing chunk level of detail. It's nobody has done a convincing job of making anything that looks good enough, because you can't. You can pick a separate texture on every face. It's really not feasible to do anything very good with that. Meet me halfway. Okay. What was that in reply to then? I don't know. I'm assuming OBS has Linux support. It does not. It only builds on VC6 right now. If somebody else does the port, it uses SDL though, so it should not be hard to make work. But I've not done the work. If somebody else does it, I will absolutely address that. Yeah. So actually, let's go ahead and say that I'm going to stop OBBGing, and I'll do my git commit here that I started to do, but I will continue to talk in chat. And in the past, I've shut down the stream once I started chat. And I've decided that that is the wrong choice, because anybody who doesn't care about the chat can at this point skip ahead to the next video if they are watching the archive. And anybody who's watching the stream who doesn't care about the chat can turn off the stream. So what are my commit messages being like so far? How detailed? Because I've made a bunch of changes. Begin new network regime. All right, there you go. We're going to do that same quality of thing. Continue new network regime. And then I will push it. It is pushed. And then I'll clear the screen and I can bring that back on. OBS, not OBBG. What was the OBS question? Oh, that's your correction. No, it's not a correction. Oh, I'm assuming OBS has Linux support. Haha, yes. Okay. Well, it was still an interesting question, right? Whether OBBG has Linux support. So indeed, it should have Linux support. And I see, I had to double check that that was not the bot. Willing to port it to Linux. OBS on Linux, yeah, I assume it does, but I'm not an expert. That was not addressed at me anyway. But so anyway, so yes, like I said, move on, because the chat may deviate from OBBG topics. I accept that, but OBBG topics are of course preferred. Done in today's stream. Fix jumping up bug. What else did we fix? Fix tilting up moves backwards. Fix something else too. Did I actually phrase it exactly that way? I remember that's what I said. I just didn't think it was as catchily phrased. How stable is STB voxel render? Well, it's super stable except to the degree that it's not been tested. So, it's had 2 fixes in the last year, but I don't know if anybody's been using it. I don't push on any, right? I use whatever slice of it this software here is using, and whichever parts I tested. It's well stated that it has a very complicated API for choosing exactly what data you want to push into it, so that because one of the biggest costs of pushing in a big giant 3D array and then turning that into a mesh is cache. One of my concerns was the cache usage of traversing that big 3D array. And of course, it's all sequential, so the prefetchers may do well with it, but I in fact found that blocking it up, even though my chunks are 64 by 64, I think I blocked them up differently. I don't remember now, because when I was playing with it, I was able to get more performance, which was presumably due to cache. So because of that, voxel render takes a whole bunch of separate 1 byte or 2 byte 3D arrays with exactly the data you need, so that you don't have for each voxel a big thing with 13 different fields, of which you only use 3. You just pass in 3 separate arrays. But to make all that work, there's a lot of different ways to do things. You can pass in colors this way, you can pass in colors that way, and most of those just have not been tested because I wasn't going to sit there and do that, because I was doing STB voxel render for April Fool's and to get that trailer out, and so I just focused on the ones I needed. And I've never gone back to it and attempted to make a full test suite. One problem is that there are so many cases that getting the interactions between the cases would be a mess, but most of them don't interact, so I don't think that would actually be a problem to get sort of a test suite that does kind of cover all the cases. I just don't really want to do the work. 10 bytes per voxel. No, it's 10 bytes per triangle of the final mesh. So for each exposed voxel, typically you have between 1 and 3 quads, and each quad has 2 triangles. Does it support transparent/water surfaces? It sort of does. It needs some work to actually extract them so that you can render them separately. There's the problem of sorting them. It used to be Minecraft didn't sort transparent stuff at all. It did a little sneaky hack, which I was originally figuring I would make my thing do transparent stuff correctly and would surpass Minecraft with that. But before I got my stuff done, Minecraft came out with fixed transparent stuff, and their water is properly transparent, and you can see transparency through transparency. And so I didn't ever bother to put the good stuff into mine. So the main thing that's needed, there is support built in that you can output the data to 2 separate vertex buffers, or more than 2 separate vertex buffers. And I don't remember how you control it. I think you can key it off the type, so you could set it so all water type things went to a separate vertex buffer. And if you do that, the problem is that those aren't sorted, and there's no good way for you to sort them because you don't know any info. It's just a raw stream of vertices. You don't know where they came from, so you don't know how to sort them. So that's a problem that I still need to address. It's an open problem on that library. Where was that question from? I don't even see it on my screen anymore. Did I imagine it? Was it a fantasy question? Oh, there it is. Yeah, okay. So continue to ask more questions about STB voxel render if I haven't covered what you were asking about in sufficient detail. Maximum number of lines of code as a limit for single header libraries. It's a feel. stb.h is very large, and I don't recommend it to people, partly because it's very large and it's unfocused and it's sloppy. It was really just meant for me, and I put it up in case it was useful to others, and now like Sean McGrath uses it and some other people use it all the time because, hey, it's already there and it does some of the things they want. All right, yeah, you're welcome, NORAD. Why is Minecraft so incredibly unstable? I have no idea. I have a Minecraft realm that I rent for me and some of my friends, and ever since 1.9, my Minecraft on my machine crashes after 5 minutes. It does graphics corruptions first because it's running out of memory, and the NVIDIA driver starts running out of memory and screwing up internally, and then Minecraft runs out of memory. And I run in 32-bit, so I'm sure that's part of why. But you know, I mean, I paid for it back when it worked fine in 32-bit. So I don't know if that's a bug in 1.9 that they're leaking memory in some way and they just haven't noticed yet, or they just upped their minimum memory requirements without documenting it or whatever, but it doesn't work for me anymore at all. And that's very specific to me. There was a rant written by somebody several years ago about how a rewrite in the Minecraft internals, they switched from passing in XYZ coordinates everywhere to creating a little point struct with XYZ coordinates. And that ranter believed that that caused all those XYZ coordinates to go onto the heap, and that change caused them to churn through garbage a lot faster. And I think he had evidence that the garbage collector was churning through data a lot faster. On the other hand, Rigorous Fabian has said that the way Java stuff works should be able to recognize that it can not put those things on the heap, that it should be able to put them on the stack, and that shouldn't actually be a problem. So who knows what's going on there? None of those things should cause instability. That's all performance stuff, and the being out of memory can cause instability. But I haven't heard anything about Minecraft being unstable from anyone other than me. The previous version of Minecraft would crash every hour or so for me. A couple years ago, it never crashed. And then starting like a year ago, it started crashing on me about once an hour for the same out of memory thing. And now it runs out of memory after 5 minutes. So that's all I know about it. And that's not a knock on garbage. None of that was meant as a knock on garbage collection. The person who, NORAD, who was commenting about using a GC language, I don't think there's anything wrong with that if it works for you. I mean, Unity uses a GC language for its scripting, and all these people are releasing VR games that have to hit 90 hertz exactly, always, all the time, and never miss. And obviously it's working, the garbage collection is working well enough there that nobody's complaining about it. So so I do not support the Jeff and Casey rant about GC. I think it's overrated. I think it causes problems in some sort of situations, but if you can make it work for you, that's great. Rock on. This is one of the many ways that I deviate a little bit from handmade. What's the word for that I'm looking for here? Handmade. I probably want sort of a religious word of whatever the conventional wisdom is, but I can't think of the word I'm thinking of. Can't think of the word I'm thinking of. Oh, that's pretty awesome. Yeah, somebody else's reply about the Minecraft thing is it was written in a not great garbage collector language and has accumulated a lot of technical debt over the years. And that's all probably true. Certainly Notch has commented when somebody was complaining about him having written Minecraft in Java, that when he wrote it, remember, we can still all look at this, of him developing it on TigSource, you know, him posting on the TigSource forums as he was developing it. He had no idea Minecraft would be the thing it is. And Java was the comfortable language for him. He was just another guy poking it, you know, making an Infiniminer derived crazy little thing. Nobody expected the results that we got. And his comment, and he may not have been being serious, but his comment, you know, was a Twitter post or something, was something along the lines of, had he known, maybe he would have used a different language, had he known how big it would still be. And made manifest dogma is, in fact, the word I was looking for. Thank you. So yeah. I mean, I should clarify, since you're going to quote it, that part of the reason I do not support the Jeff and Casey rant about GC is because he says, we've worked with it and it has all these problems. And he's talking about a different thing, which is he's talking about the fact that Iggy implements garbage collection. And the thing I have learned from implementing garbage collection in Iggy, which is the project I work on at RAD, that I avoid talking about work because I don't want to cross the streams. What a terrible pun. Is it would be a pun if there was a rad stream. There isn't a rad stream, but the Iggy experience is that it is Iggy experience is about implementing GC when he's talking about how bug prone it is, and it's only bug prone because of a certain thing. A lot of people, when they are trying to do a garbage collector, see like system, they'll use a conservative collector rather than an exact collector. And it's conservative. They're always conservative in a certain sense. I mean, in a technical sense. But the easy technical thing to say that requires you to know something about garbage collectors is never. So they garbage collectors. I don't want to try to explain it. So it's the lesson is never force yourself to write garbage collector mutator barriers by hand. That's the technical basis, and that is the lesson I learned from that. And Jeff tried to apply that as saying garbage collection is bug burn, but it's not. It's writing garbage collector mutator barriers by hand is bug burn. And when you use a garbage collector, the compiler is putting those in for you, and you never have to worry about it. And the problem is that in Iggy we implement the ActionScript3 class library, and that's all implemented in Z. And so all that C code is full of code that was not generated by a compiler that knew about the garbage collection. It was written in C, and so the code manually has to know about the garbage collector, and it's constantly having to annotate things in a certain way. And if you ever miss one of those, the code all runs 100% perfect until a garbage collection happens at the wrong time, and then you randomly corrupt your heap in some unpredictable way that might or might not be visible. So that is the actual thing that I experienced that I feel like Jeff misapplied in that thing. And there's part of why I don't support that rant. And part of why I don't support that rant is because, yeah, I'm like I said, I deviate a little bit from handmade dogma in some areas. It's an interesting twist because for a while we kind of had this philosophy that, not we, like let's say performance is what you care about, just to simplify. There was sort of a philosophy of like, let's say I'm trying to make a 60 hertz game, a 60 frames per second game. There was an idea on the PS3 like that you use the SPUs, the magic cell stuff, that I suppose is still under NDA, so I can't talk about. But and what the smart people would do is they would wait until the game was no longer running at 60 frames per second, and then they would move some of the stuff onto the SPUs because it's a pain in the ass to put stuff on the SPUs. And so they just keep doing that. Anytime they fell below 60 FPS, okay, now let's get it back up to 60 FPS. You could upfront try to put everything you can on the SPUs, but that may just be wasted work. If you're going to hit 60 hertz without doing the work, why bother doing the work? It's a little opposed to the handmade philosophy of just doing it all right always. And that's kind of that's probably an exaggerated attitude towards the handmade thing. Yeah, maybe on the handmade thing you're okay with, maybe this is all actually within the handmade philosophy. Maybe I'm overstating the handmade philosophy there. Don't do the work unnecessarily. Don't do the hard work unnecessarily there. You always want attention to detail, but right, you're aware of the issues. But the side thing from that is that now with the pressure on mobile, this is all different again, because now the pressure on mobile is to preserve battery life, which means to always be efficient on everything. That attitude that we said made sense on the PS3 trying to hit 60 FPS, of only trying to super optimize it if you weren't meeting the 60 FPS, is no longer true. It's like, no, like if you can get it to, run at 120 FPS, in other words, run at 60 FPS and be idle half the time, that helps your battery life. So maybe that, the point there was that the 60 FPS idea also applies to all these other things that we're doing. And I don't even remember what we were talking about to bring this up originally, maybe the garbage collection. If it's good enough for you, if you're running Unity, writing a 2D game, and you use a garbage collector thing, you use Flash, and it's good enough, it runs at 30 frames per second, and it's a game that wants to run at 30 frames per second, then who cares? If the garbage collector is causing big obvious pauses, it's a problem. But if that's not happening, who cares? And maybe you could advance an argument now that, well, using these garbage collected interpreted languages is wasting power. But that's a different rant. There's a rant that, of course, Jeff and Casey have talked about, the using native code rant, that I think was specific to mobile, because Android is the big case where you have that, where the native, the preferred language is JIT. It's a JIT rather than whatever. So who knows? I don't know. It's all crazy and messy. I don't really think about memory management much, and it is relatively trivial, yes. Partly that's due to certain strategies that you apply and may not apply in all situations. And I've talked elsewhere about how, I think this didn't come up in the HandmadeDev, so I'm not sure where I've talked about it. But I've talked elsewhere, I did talk in the HandmadeDev about the idea that I started working on this other programming language, but I don't think I gave the details about why I gave up on it. And I have talked about this elsewhere, though, which is that I did stb.h and did two data structures in it, the dynamic array, which is like vector in C++, and hash table, mainly the hash table mapping strings to strings to pointers. And for writing tool code, that fixed 100%, 99% of the cases. And all the other stuff in stb.h, loading a file in one thing and stuff like that all helped as well. But that memory management is particularly interesting because the dynamic array is this very explicit replacement for malloc and realloc, a certain case where you kind of had to always be messing with malloc and realloc if you were sticking with C. It's the same as vector in C++, the same overhead or mental overhead. You still have to worry about ownership and things like that. But yeah, you typically don't spend that much time doing it. And then if you're doing a game, it's just things have different kind of model of lifetimes. Like a lot of the times in the game, you have your simulation objects that just have a lifetime, like you destroy them in the simulation explicitly. And the question is, do you have a lot of objects outside of your simulation objects? And that's the object-oriented programming thing, right? Like if you don't even have that much else to manipulate, you know, maybe you have what do you have in a game? You have some other data structures running stuff. You have, you know, particle systems that maybe have their own memory for the particles, and you have this other stuff. There just aren't that many places. You know, this is not a good example at this point because this is too small. 4,500 lines of code. Do I have something that's bigger? I don't know if I have a working program that's bigger. I mean, so here's an example. So I have this game called Promesst. Where did games done with? Yeah, it's only 2,000 lines, so it's really hard to use this as an example for much. It's this 2D game that I made, you know, and here it is. It's just got a bunch of code. It's at the very beginning got the map. Yeah, so a little ASCII part. Here's the map for this game. It's this little game that's a little simulation. It simulates these little beams shooting around the map, doing various stuff. None of that requires memory allocation. So if we say grep malloc.c, save games, it mallocs the undo restore gets malloc. That's the entirety of malloc usage in that program. So how much time did I spend worrying about memory management in this program? Almost none, because it was literally just for this undo. And if I just give a fixed undo limit, instead of having this program, it will just keep consuming memory as you run it, packing up this giant undo history. If I had just put a fixed undo limit and didn't let you undo past it, I'd be able to get rid of that one now too. So in the game scenario, it's really common that you have these simulation objects that you just go ahead and do a fixed size array for them or whatever. But even if you are mallocing, there just aren't that many cases. So in OBBG, I have to be careful about this because do I have any library sources in here? So the mesh builder, other things are doing the free because of the threading. And there might be a realloc. Or there might be, some of these frees are probably STB. No, those are all mesh builder. Those aren't actual frees. These are actual frees. I don't know where they get malloc. Oh, they are. Yeah, this is the threading stuff. So I don't know what those two frees are, but like it's just how much of my time got spent on those? Not very much. All right, so there were a bunch of questions after that, or at least 2 questions after that. So let me go back and catch back up. And that is why I do think garbage collection is not a big deal. Like it's not a big, there's really no need for it most of the time. However, if you're in an environment that happens to be garbage collected, that's not a big knock. That's what I kind of meant. I wouldn't seek out garbage collected environments myself because I don't think they help enough. And you do run into the potential problem if you're in a garbage collected environment and you are trying to do a handmade level of detail, attention to detail, that if you start needing to have memory problems like the Minecrafts maybe are now, you don't have very good tools to deal with it. About all you can do is cache objects. I mean, I don't know. I'm not an expert. So the biggest thing you can do is cache objects, which is basically doing manual memory management. And people say, well, hey, at least you only have to do that manual memory management on some of the things. But it's kind of like it just wasn't enough manual memory management in the first place to pay the garbage collection overhead, performance overhead. So who knows? As I haven't written a GC, only know the basic theory. Could you write a GC where you could still use free and have that pipe flew to the... I do not believe you can free if you have a garbage collector because, I mean, it kind of all depends. So the garbage collector, one of the things a garbage collector offers you is it helps with type safety. And if you have a type safe language, which C and C++ aren't. One of the kinds of type safety, one of the issues that you run into type safety is dangling pointers. If you have a pointer to something that's been freed, that dangling pointer is invalid. It's not actually type safe. So pretty much I think every language that claims to be type safe is garbage collected, except Rust probably isn't garbage collected and still claims to be type safe because they do other things to manage, to guarantee that you don't have dangling pointers. And I don't know any of the details of it. I just know that that is true. If you try to free it and you're garbage collected, you're explicitly freeing it, and yet there are still these dangling pointers. So what are those pointers pointing to? Now, it is possible in some garbage collectors you have things called forwarding pointers where you leave a pointer, when you relocate an object, you leave a pointer from the old location to the new location. And so you could imagine freeing something and leaving a relocation pointer that points to nothing, is null, or something in some way that flags that when you try to use it is dead. But what do you do when you try to use it in that scenario? Do you throw an exception? Do you treat it as null? Maybe you could treat it as null. Maybe when you try to access that pointer, it turns into null. Like that's certainly an old strategy used in older systems where you just have this big object table. So your pointer, what you would normally think of as a pointer in a code base is actually just an ID into an array, and the array points to the final object. So then when you relook at the object, you just update the pointer in that object table. And if you free the object, you just set that to null. It's basically weak pointers. You have to, when you load the pointer, check if it's null, if that's possible. And so your whole code base needs to be doing this extra null checking. So if you have libraries that weren't written to expect that, if your libraries thought they were GC'd and aren't checking that their pointers suddenly turn null under them, it's not going to work. So it's a hard problem. And people have tried to do these mixed mode languages. People were trying to do versions of C that ran on the C# thing. And Microsoft tried several different versions of that, and I don't know if any of them have turned out. It's just turns out to be a hard problem to have mixed in a single code base, having some things that are malc freed and some things that are garbage collected, is my understanding. I do not have any experience with it in practice. Regarding physics, when both client and server do the same, how do you make sure both sides produce the same results? Glenn Fiedler, and I think Bruce, what's his name? Bruce, why can I not remember his name? The ex-Valve guy, Bruce. Dawson. He has written about this as well. I will cut and paste the link if I can find the right one. Floating point determinism. Will you always get the same results from the same inputs? The answer is an unequivocal yes. Unfortunately, the answer is also an unequivocal no. So that is the short answer to your thing. And I'll paste the thing into chat. And the actual answer to your question is, I am not doing lockstep peer-to-peer simulation. It does not matter if the two deviate. The client, the server is always authoritative. The results the server generated are always correct. The client attempts to predict it and run the same calculations, and if the client turns out to be wrong, it will be corrected when the server returns the results. If those results are incredibly close but only slightly varying in the floating point, the final fractions, then you'll just never even notice that it happened. It will just deviate slightly and be corrected constantly. If the two are widely inconsistent because things happen differently, the timing of when the server was aware of a collision or whatever was different, you will jump around on the client when it gets corrected. But they will, in fact, the client will be simulating the physics. This is a follow-up question. But it's not authoritative. The client simulates the physics to avoid latency. It doesn't want to wait for the round trip from the server to find out what happens when the player does things. So it runs the physics locally to find out what happens when the player does things and hopes that that's correct and shows that to you on the screen. And most of the time it will be correct. The only times it won't be correct is when some object got in your way that you didn't know about. That's for the player movement. For anything else that's happening, you kind of just want it to be whatever the server said happened, because if you try to predict it locally, you'll be looking at out-of-date data and just get it wrong. And so that's all that addresses the problems with the floating point not matching, because the server is running Linux and the client is running on Windows or something like that. That's all fine, because they'll both run the physics and they might not be exactly the same, but it doesn't matter because only one is authoritative. Consoles do have virtual memory, because they do actually need protection. The virtual memory is only for protection. They're not swapping to disk or anything. So that's not really why the fixed arrays are fastest, but is John Carmack really good? I think I'll set that aside, because a meaningful answer, good is such a kind of fuzzy, meaningless word. But I was going to say, even the older consoles had virtual memory just because they had the dashboards or whatever that needed to be protected from the thing, so they did run as separate processes, I believe. So a benefit of using float instead of double nowadays? Yes, the cache usage is half, and the processors are still faster mostly at floats than doubles. So if you care about the performance, it's worth it. Have you looked at Rust bar lifetime system? No, I've not looked at it at all. I don't know anything about it. I name dropped it, as I said, because I know they are doing stuff about it. I have never looked at it and don't really want to know, probably. Things should be easier with integer only. So the voxel engine that I was working on, it was actually faster than the STB voxel render in some ways. Before I wrote STB voxel render, and the STB voxel render I wrote to cache in the experiences I had from that other previous game. An unfinished engine. I wanted to get some of that knowledge out there for other people to use. And that one used fixed point, so integers everywhere for coordinates and movement through the world and stuff. And partly because I was thinking maybe the integer stuff would be faster, because you're using fixed time steps, because I talked about why fixed time steps are nicer. And so you don't have to multiply by dt, because you use a time scale, so your dt is always 1. And because integer multiplies are still often slower than float multiplies at this point, or something like that. It's something nuts, or maybe they're the same speed. But integer adds can be faster. Maybe that's less true now that we've gone to the SSE scalar float stuff in 64-bit, but on the 32 bits, it's still often true, because the SSE stuff is not on by default. You get the x87 stuff. So the integer, an integer add in particular, can be expressed with the LEA instruction in assembly, which is load effective address, which does an address calculation. The reason that instruction is interesting is because on the x86, every operation is destructive. You overwrite one register with the new result. So you add EAX, EBX, adds the value of EBX into EAX, and so it's the equivalent of writing EAX plus equals EBX in C. is what this instruction would do. And the instruction LEA, EAX, EBX plus ESI computes this sum and puts it into a third register. And it's one of the only instructions in the Intel architecture that lets you not destroy a register when you do it. So it turns out that adds in the x86 instruction sets are particularly optimal. In one old version, I don't know if LEA did, but integer adds in general actually ran twice as fast as every adds, ORs, the logical ops all ran twice as fast. Plus, you had this advantage of the non-destructive register thing. That was the Pentium 4 that was a terrible architecture. But so this little trick just I mean, you have register renaming and things and a very limited register pool, so it doesn't always help that much, but it does help a little bit. And so, like, for example, as a rule, if you have 2-bit fields, like say you have say you have this. Let's do this. The classic way of doing bit field operations is to OR them together. That's just the way people think of it, because you're just combining the bits. It's not math. You're combining the bits. But notice these don't overlap, the whole point of this. And so it turns out, although compilers can be smarter than this, so this is not a hard and fast rule, but it turns out if you write this, even though it has the exact same meaning, so compilers could figure it out. There are other cases where the compilers can't necessarily figure it out. If you know these don't overlap, this has the exact same meaning. You could imagine a case where, like, this is a UINT16, and I don't shift, but I know they don't overlap. The plus can be generated with the LEA. And in this isolated function, it doesn't matter, but when you're doing this in the midst of some other code, the plus can be generated with the LEA. The OR has to use an OR instruction, which is destructive, doesn't have the 3 operand form. So it turns out that the pluses are kind of convenient. Anyway, so the fixed point doing things with pluses meant you went down the LEA path, etc. So I did have this idea for that voxel render, and it avoided the floating point problem that as you get further from the origin, the numbers get less precise, which is what led to the far lands in Minecraft, which don't exist anymore, although there is still the guy walking to the far lands in Minecraft, Kurt J. Mack on YouTube. And so in my engine, the world would just always end when you got to the end of the 32-bit fixed point, but it kept the same precision all the way out to that, and that was pretty far. I did the math, and that's, multiple US's wide or something like that. So at the scale I was thinking about. So, whatever. That was an interesting idea. I decided for OBBG that was too confusing, and I would use floats. It does mean that you can't get that far from the center before you start getting some weird behaviors. In fact, I look up Kurt J. Mack on YouTube and look at one of his far lands or bust videos and look at when he moves around how weirdly jerky the world is, and you will see floating point precision when you're far from the origin. It's happening right there on the screen with him. Some things are stable because Minecraft does the math in the right order so that those things render consistently around him in the world, and some things move in this really jerky way that you can see he's only got a few bits of floating point precision below the integers the voxels are, so he can't move smoothly to every position, to arbitrary positions between voxels anymore. Blocks, sorry, in Minecraft. All right, what else? So a bunch of questions about Rust, integers only, optimize for cache size instead of just testing different memory sizes. So there are algorithms that are called cache oblivious, I think, where they are just designed in such a way that no matter how big your cache is, they are optimal. Only some problems can have solutions that work like that. You can sort of imagine that it's like if you just need to iterate through an array once, iterating through it once is cache optimal, right? Like that's trivial statement and meaningless, but it is it's cache optimal no matter how big that cache is, right? It doesn't. There's nothing better you can do, and you can imagine that, like doing a whatever you call that recursive fractal walk. I've forgotten the word. In 2D, you could imagine it might be cache oblivious. It might, for some kind of 2D cache, might turn out to be always as optimal as you can get. So that's the idea, is they've tried to figure out some algorithm that works as optimal as you can. In practice, though, yeah, you pretty much have to tweak and measure. And of course, then you're just optimizing on one machine, and on some other machine, it may not be optimal. Which is, the classic thing we used to do in game dev in the 90s, at least, was tune for the lowest end machine. And the higher machines would run faster than that. And let's just tune for the lower end machine. That runs into that same sort of like battery optimization thing. Maybe for the people with the high end machines, you want it to run like, hey, they've got the super duper machine with the SLI and all that, and they should get 90 frames per second, where the slow machines get worse, and that's not the right trade-off. Maybe you have to do the work on multiple machines. It's all a mess. I don't know. I have just tuned STB voxel render. STB voxel render is oblivious in the sense that you, as a caller, are responsible for deciding how you want to split things up for cache optimality. You can do it in any ways you want. It's not cache oblivious. It's cache independent. I don't know, there's maybe no good word for that. But then I did do that work on my machine in VC6 for STB voxel render trailer, basically, even though it was just a little number up in the corner in STB voxel render trailer. I mean, so I was trying to get STB voxel render as optimal as I could, only testing on one thing, which does not make it as optimal as it could be, but at least it's optimal in the one case that I was trying. But yeah, you can absolutely not know about it in some ways. A lot of things, though, get pretty complicated and are unpredictable in ways that do make it hard to know about it. You have plenty of rules of thumb. To make your data smaller is a good rule of thumb. So use floats instead of doubles if the floats are going to work. It's never going to hurt your cache usage. So I mean, I guess you could imagine, you can construct really weird artificial scenarios where it would hurt because things have to align to cache lines with doubles and don't with floats or something. But randomize your memory layout, and floats will always be better than doubles for that side of performance. Yeah, GCC will have to distinguish between those if they're not UN8 sized, because it doesn't know that they're, oh, you did use UN8. So yeah, and if you look at that assembly, so this person just actually tested this, you can see that they're actually exactly the same length. This one did use the LEA rather than the add, but there's no real good reason for it to have. The OR is already in the right register anyway, so it could have just used that same code and put the add there. It's only when you're in the middle of other code and you like don't want to stop that register because you might be reusing it that this comes up. So it was sort of just a trivial side bit that I bring up because I do have the habit in my code of writing plus where many people write or, and that is literally why I write plus where other people write or, is because I know LEA. It can't hurt. It doesn't really matter. On any other architecture, the cost of the add and the or are the same. The add is more complicated in hardware because it has to carry and the or doesn't have to carry. But that doesn't matter. I don't think it's ever going to affect power significantly. And they're always going to take the same number of cycles in practice because they tune for the add. And they make the or slower so that it runs the same speed as the add, because that's how you make computers work. Register spill is a non-trivial topic. That is indeed true. And of course, one of the things is that the x86 has so few registers that this is all just crazy. But it's also true on the 64-bit version, which has more registers. I think I'm all caught up. So if you have more questions, keep going. But if we run out, I will stop. And if I miss something, please restate it. Yeah, and I didn't even talk about how LEA also has a multiplied by 2 or 4 or 8 in it. That is just potentially free. It's on some hardware, it's actually free. I think on some microarchitectures, it is actually free. Does not take any extra time to do that extra multiply. It's just a small shift. And on many microarchitectures, it splits those into multiple internal micro-ops and takes just as many micro-ops as it would to explicitly separately do a shift and an add, so it doesn't help. But on some, it might. Have a look at Agner-Fogg's architectural proposal. Yes, some of it seems a little pie in the sky. I'm not really the right person to comment on it. Pie in the sky is not even the right word. Unacceptable from a hardware engineer standpoint. Like, I feel like there are some issues that he's not aware of or not considering, but I'm not an expert on it, and so I'm not really wanting to go into details of the criticisms there. I'm not a person who should be critiquing it, but in other words, it might be valuable. I don't know if anyone is out there. It might be valuable to see whether anyone considers it crackpottery. I don't know if it crosses that line or not, but if it is crackpottery, it's not really even worth taking seriously. We're agreed on to support round pillar column blocks and 1/4 slopes. It does 1/2 slopes array if I recall. It does 1/4 slopes. No, it doesn't do 1/4 slopes. Yeah. It does weird steeper slopes. You can do a slope that sticks up to 1.5, so it sticks out of the current voxel. What by round pillar columns? What do you mean by round pillar columns? But the answer is a lot of work, and I can explain why. I have a new design that makes a lot of that stuff much more tractable, but the current design is kind of impossible. Like, you actually, by round in quotes, you actually mean round. I mean that they obviously are not infinitely round, but they are reasonably tessellated. They're not cubical. They're not pillars that are cubical but small. You actually want them to be quote unquote round, which is why you put quotes around your round. Okay. So the problem is that the way SB voxel render works is that it packs the vertex coordinates down very small as fixed point numbers. And the current design does not allow any flexibility in that. I certainly had considered that for like the quarter height things. So what it does is it stores the x and y coordinates as integers and stores the z coordinate with 1 bit of extra precision, which allows it to do half height blocks. Because that's what Minecraft has, is half height blocks. And the stairs have coordinates that are halfway across the thing. So to do the Minecraft stairs, you would actually have to get an extra bit of precision for x and y. And the reason SB voxel render does that is because that lets its triangles be 10 bytes. So the thing to remember is that in a lot of graphics, we share vertices between triangles, and in a voxel engine like Minecraft and SB voxel render, quad can be two triangles that share the vertices in the quad, but the quad is actually independent of, you can't share vertices even if they're adjacent side by side facing the same way. Those two vertices can't actually be shared because they probably have different texture coordinates. They might have different textures on them. You might want unique vertex lighting values on them. They might actually be shared vertex lighting values. What's a good case? There's various stuff that could be varying between them, so it can't share them. One of the things people doing voxel engines talk about is building them at that level of sparsity, but then merging and trying to eliminate vertices. And it turns out, like, you just in real scenes, there aren't enough vertices to eliminate to make that worth doing. So SVU voxel render to keep that mesh data small, because I want to do these very large vistas, and that takes a lot of mesh data. Wants to keep them small, and so I compress these x, y, z coordinates down very small, so they are just 6 bits for, or the 64 by 64 chunks. It turns out you need to express the number 0 to 64, not 0 to 63. So 6 bits isn't enough. So it uses 7 bits for x, 7 bits for y, and 9 bits for z. That lets the z go from 0 to 255, or 256, no, 255 only. And so it's 1 shorter than Minecraft. And the 1 extra bit in the z lets it have the half height precision. It gets down to 10 bytes per triangle by cheating and being 20 bytes per quad. The way it's 20 bytes per quad is 4 bytes per vertex, and then a 4 byte shared data for the entire quad that has like texture, which texture to apply to it and stuff like that. So the 4 bytes for each vertex are, X, Y, and Z, or would be 8 bits each. It slightly packs them a little bit differently. And then there's the vertex ambient occlusion effect, the vertex lighting. And there might be another thing in there. Yeah, the morph factor, because you can blend between 2 textures if you want to do like a ground that transitions between 2 textures smoothly. It has a little blend factor that's just a couple bits. And that squeezes everything down into 4 bytes for that vertex. And then the extra 4 bytes has the 2 different textures that you can choose and a color and some other data. And so there's no room in that format to do like a rounded pipe, because there's no precision to express that. And to do quarter height things, you would have to limit the height of the thing to only 128 tall, and you could still do them, but the way it generates using tables doesn't have any way of generating that data. You'd have to write a whole new set of tables to generate the quarter height things, and there's issues with like how you handle the boundaries between like a quarter height thing and a half height thing and stuff. And yeah, and Minecraft goes ahead and has like the snow that can do all the really fine grained stuff, and that's because Minecraft doesn't try to pack the data down that tight. So it's a trade-off. One thing you could do with SVU voxel render is pump everything through SVU voxel render if it can be expressed with SVU voxel render, and then when you want those things that have slightly more accurate heights, don't send them through SVU voxel render. That's good for like doing a little thin thing of snow on top, or a rug or something like that, as long as that's not everywhere. But if you're allowed to just go add them everywhere, if the player is free to add them everywhere and is going to add lots of them, then you no longer get the win of the SVU voxel render, because you'll end up with a lot of your data not being the skinny, the tiny vertices. So there was a different strategy that I have now for this, that would make this all possible, and some of it's documented in SVU voxel render. They have the plan. There's some info about sizes, I think, that includes this strategy. But I probably didn't post any of the details in there, and I don't know if I'll get to it. And the idea is it would allow you to have maybe it would probably, so like if your pipe had, say, 16 faces around, if that was enough rounding, you might have room for 256 face types, and that round thing would have already used up 16 of your face types. So like your normal voxel shape uses up 6 of your face types for the 6 sides, and the half height thing uses up a face type for the thing, and actually you need these half height side things, so it uses up 5 face types, and the other side of the half height one uses up another 5 face types. And you'd probably be limited to 64 or 256 face types. So you would get to pick some things to have the subtler detail, to have the I don't remember which Minecraft thing it is that doesn't extend quite all the way up to the top. You'd have some room to do some of that kind of stuff, and it would need a whole new generator for it. And it just uses a totally different method for packing vertices that's more that splits the coordinate data between storing it in the vertex and storing some of the info in the face and storing it in an indexed in the face, so the face just stores one of the 256 face types, and then the shader looks in some tables to decode what that face is supposed to look like and applies it to the vertex. So it's a very complicated, different way of implementing STB voxel render. It would be a bunch of work. I've thought about doing it and not putting it in STB voxel render. Thought about putting it in my own secret code base, like turn OBBG into that someday, fork it back to a closed source thing and put some of that smarts into it that would let me do more intricate stuff that you can't currently do in the current stuff. You could also abandon the current compact encoding. There is a mode of STB voxel render where it just uses floats. But you still need to generate a whole new set of tables to support those other kinds of things. And yeah, if you just use the float mode, it's way less efficient. There's some size info in here somewhere. Here it is. 32 bytes per quad. How does that one work? No, there isn't actually float mode. There used to be a float mode, but maybe in STB voxel render I never put it in. So yeah, you'd have to actually add a new mode to STB voxel render that has a float mode. And the data would be twice as big probably as that. So it would probably be 64 bytes per quad, maybe bigger. That would be the easier thing. That would be a mod somebody else could even make to STB voxel render, because it wouldn't be a dramatic change to a lot of it. All right, next question. What machine version is still worth generating for a decent indie 3D game? I have no idea. Different normal, no shared vertices. Yeah, but it doesn't even have to be a different normal if you're just looking at a flat face, because the textures might be different, and so they have different texture coordinates, even though they share the normal. How would you go about adding arbitrary 3D model objects to the voxel world, like say a chair or fence? Well, you'd just write a separate renderer that renders chairs and fences, and if they're freeform objects, that would go through the object system in OBBG, for example. If they're meant to be terrain types, if you place terrain blocks that turn into chairs, you could either do the thing we were just discussing about trying to actually make that be generated by the thing, or you just intercept that block type and generate the vertex data yourself and render it. So, I mean, there's lots of different strategies. It's such a vague, open-ended question. The magical thing about the Z buffering is that you just can render things with different renderers, and they all live in the same world, and the Z buffer resolves the issues between them. So you don't need smarts to connect them. You need smarts to make the lighting match up between them, and lots of other stuff. But the core question of how to get them both rendering is you just draw them. Expand on that question if that's not a useful answer. Okay, I'm caught up again. So if I missed anything, re-ask. And it's slowed it down enough that I will, in fact, stop the stream at this point. But if you do have more questions, go ahead. But if you're watching the archive, thanks for watching. Hopefully there's another video for you to watch. Bye-bye.